This conference will now
Yes.
be recorded.
Good morning, everyone, and I'm Pratik. I have experience of 10 years in industry, physical design. Right. So today agenda I'll discuss on these four things in physical design demo. First, I'll discuss about VLSI Guru session structure, right, how it is. Next, I'll discuss on placements. Next, I'll discuss on what is physical design. Next, I'll discuss on our course content. Right. In VLSI Guru session structure, how sessions are conducted. See, we have two parts. One is PD basics, one is PD advance. Right? We will divide our course into two things. See, first I'll tell about course duration. Course duration is 6 months. So we will divide this entire course into two things. One is PD basics and another one is PD advance. See, in PD basics we cover which is at most compulsory, which is required for PD advance. See, without this we cannot do PD advance. So what are the things we cover in PD basics is we cover, first we cover digital basics which you already know, but we are going to brush up once again, like what is sequential cells, what is combinational cells, what is difference between sequential cells and combinational cells, what is flip flop, what is latch, what is difference between flip flop and latch. At least these things should be known to any engineer who is working in electronics domain, right? So next we discuss on, in this PD basics, right? We will discuss on GVM basics. What is GVM? GVM is an editor used in Linux environment, right? So whatever editor I am using here is text editor. You know how to use text editor. Control S is for saving, right? Next, go to next line means enter, right? Similarly, how to use GVM basics. How to use this GVM editor. What are the shortcuts for that? How to save a file. How to exit from a file. What is command mode? What is insert mode? So all those things we are going to discuss in GVM. How to handle basically that editor. Because in physical design or in any VLSI domain, we will not use any other editor. We use only GVM editor. Right? We'll discuss on this GVM editor. So third thing we will discuss on Unix commands. So Unix is an operating system like Windows. It is different operating system. All EDA tools are installed in Unix operating system. EDA means electronic design automation tools. So whatever tools we use for physical design or for front end, every tool is installed in Unix environment. So if you use Unix operating system, you have two options. One is use GUI method. What is GUI method? If I open a folder, right, like this folder is what? GUI method. Create a folder, right click, new folder. This is a GUI method. But Unix has a command method also. How to create a folder, how to go from one folder to another folder, how to copy a folder, how to copy file, how to link, do the soft linking, what is grep command, what is find command, what is awk command, right? Different commands in Unix we are going to study. So that is called as Unix commands. Totally, what are the commands present in Unix? We will study, including the commands for giving permission for files. So next we will, you have a course for Tickle basics. Tickle stands for tool command
Command language.
language. Yes, please tell me any doubts you have online. I can see someone talking in between.
So nothing, sir. Tool command language.
You were telling what is TCL, right? Full form of TCL. Yes, good. So TCL stands for Tool Command Language. See, for physical design, especially TCL is very, very important. Without TCL, there is no physical design. Because EDA tool, what we use for physical design, that can only understand tool command language. Right? So we are going to cover complete of tool command languages, starting from the set command, setting and variable, till dictionaries. Right? We cover all the content of TCL. So next will be your CMOS basics. This is very, very important. In CMOS basics, we cover what is semiconductor, what is N type, what is P type, what is MOSFET. So what is CMOS? Different types means different gates implementing by using CMOS. What is layout? What is fabrication steps? What is FinFETs? So all those things is covered in CMOS basics. And little bit of PD basics, not in depth, just it is for 1 day or 2 days, just to understand few terminologies. So we do some PD basics. So all these things we cover for 2 months, or sometimes it may take 2.5 months, not exceeding 2.5 months. This is just a upper bound. Right? So our schedule is 2 months. Sometimes it may take what 2.5 months if the batch is very big, because clearing doubts, handling all the students take a little bit more time. Then at last it can end up to 2.5 months. So out of 6 months, 2 months we take for PD basics. So all these things are covered in PD basics. Next, PD advance. See what we cover in PD advance, I'll discuss later. What is physical design and our course content, I'll discuss later. What is covered. Just now I'll mention how this course, how this session structure is. Right. So this PD basics, we can have weekdays class and even weekend class. See, weekdays class will happen for 5 days a week. Monday, Tuesday, Wednesday, Thursday, Friday, or sometimes 6 days a week. Right. But weekend happens only on Saturday and Sunday. See, this weekend is only optional, only for the candidates who cannot attend on weekdays. There will be some working professionals who are enrolling for the course and they cannot attend on weekdays. Only they can enroll for weekends. Others who are not working professionals, you can enroll for what? Weekdays. Don't you cannot attend both, right? If you attend both, there is no restriction, but it is lost for you because same thing is covered, right? So attend any one thing. My suggestion is go with weekdays, and if you are working
Six
professional, then you can
days.
go for weekend. Yes, please tell me any doubts online. Someone interrupted me in between. Any doubts? Okay.
So, like, I have a doubt.
Yes.
Pritesh. So what is the duration for the weekdays? Like, how much, and the weekends? What is the time? Like, how long
See,
is the week?
weekdays for every day it will be 3 hours. Here also it will be for 3 hours.
So, how do you cover like 5 days in 3 hours in Saturdays, weekdays?
See, weekend we have only less student. Right? Hardly 4 to 5 will enroll. Not even 4 to 5. Every student will be on weekdays. Weekdays we will be having almost 60 to 70. But a weekend we will be having 3 to 4. I think you can understand now what is a trainer load is, right? So here almost 10 to 15 students will ask the doubt, but here hardly two will ask the doubt. So we can cover that same topics.
Okay, you're saying like you give more time for the doubts in the weekdays.
Yes. See, if I go with pickle, right?
Okay.
See, all this only digital basics is I can tell it is a presentation, right? Presentation and doing some assignments. It's not only presentation, even you can parallelly work. Like, see, digital basics starts from K-map. So they'll help you how to come up with the Boolean equations. So it is like working along with the mentor also. But all these things, GVim, Unix, Tickle, right? It is hands-on. It's not presentation wise, right? Hands-on means mentor will do along with the mentor. You will also do parallelly with your laptop. Mentor will help you to install the tools. He'll help you along with the mentor. You will also do parallelly along with him. So he will type one command. He will explain for what purpose the command is used. He will show how to use the command. Parallelly, you will also work with it, right? So here, this is done at a time for 40 students. But here in at the weekend, we have 4 to 5. I think the same topics can be covered.
Okay. Sounds good. Thank you.
ప్యాటర్న్ ఒకటే ఇది ప్యాటర్న్
So
ఒకటే
these things are hands-on. So only digital basics is not hands-on because it's purely digital, but it will be like uh, you should work along with the mentor. Like he will give some Boolean equations, come up with the K map, right? Reduce the Boolean equations. So implement the counters by using the flip flops. So there will be like some exercise type of things in digital, but these three things are hands-on, and CMOS will be a presentation type, and PD basics is just for 1 day or 2 days, just to help with some terminologies. What do you mean by core area? What is die area? So what is ASIC design flow? So like that's few things, some basics of PD is done. So this is done for 2.5 months or 2 months, and recorded video is given. We will give recorded videos to help the students if you are unable to attend the sessions due to some reasons, right? You can see the live recorded. If these recorded videos are not pre-recorded videos, it's live recorded videos. Means if I do session today, after 3 hours, we will upload the recorded video to your portal. For every student, the portal will be given. We will upload the video. So we will upload the video in the portal, and you can see that video after 3 hours because we need a 3 hours time for uploading. So
So
this live recorded.
those videos remains there till the course completed, right?
No, these videos will be refreshed for every 15 days.
So we don't see the videos before 15 days.
No, this will be refreshed for every 15 days.
So we can download the videos,
No, you cannot download the videos, but you can watch the videos.
but you are saying that
Along with
50.
recorded videos, you will be given pre-recorded
మీరు
videos.
వెయిట్ చేస్తాను చేసుకోపో
See, please mute yourself, right? If you don't have any doubts, because I can see students talking to with their families
అసలు
or
సంపులో
candidates
నీళ్ళే
talking
లేవు
with their
అయినా
families.
ఎత్తేస్తున్నారు ఆ సంపులాగా ఉంది ఆ వ్యాప్
So pre-recorded videos will be given. So these videos will be there till your session ends, means your course ends. Pre-recorded videos is a video which is done by some experienced trainer. So even we give live recorded videos as well as what pre-recorded videos. This is from experienced trainer, and this is the live trainer session. So live trainer session will refresh for every 15 days, and pre-recorded videos will be there till your course duration. So when I come to PD advance, right? PD advance we divide into weekdays and weekends. So first I'll discuss about what the tool we use, right? PD advance tools. So tools used from Synopsys tools. So we use DC compiler, we use Fusion compiler, and IC validator, prime time, star RC. So each tool is used for particular reason, right? DC is used for synthesis. FC can be used for synthesis as well as physical design. ICV is for physical verification. Prime time is for prime time, and star RC is for timing sign up. So we use tools from Synopsys, and even we have tools from Cadence. So the course will be done with the tools from Synopsys. So even you can use Cadence tools with some additional reasonable amount. For example, if you pay additional 2000 rupees after completion of course, you cannot use at the beginning because you don't know what is a flow. After completion of course, you can also use the Cadence tool with some additional reasonable amount like 2000 or 3000. It will not be more than 3000. But our course will be done by using Synopsys tools. So industry uses two tools, either they use from Synopsys or from Cadence. From Cadence also we have all the tools: Genus, Innovus, and Tempus Physical Verification System (PVS). These are the tools we have from Cadence. Even you can use the tools from Cadence also. So these tools we use. See, this is our course structure that I told I'll come later, right? I'll discuss that later.
Excuse me, sir.
So I'll come to this course structure later, right? I told I'll
Excuse me, sir.
discuss. I have the today's discussion agenda. I'll come later. Yes, please tell me.
Sir, will you provide the Synopsys latest version or a new version, sir? Like the old version? Because some institute they provide like old version, like ICC Synopsys that thing, and there is a difference between the comments, no, sir. ICC2 and ICC1. So the reason.
See, we will never use ICC one. ICC old one is gone. It was before 5 to 6 years. I think no one will use ICC one now. So we will see we stopped using ICC one 4 to 5 years before. Now we were using ICC two. Even we are using advanced version now. See, first was ICC one. Next was ICC two. Next was Fusion compiler. So we are using Fusion compiler. We are not using even ICC2. Even we have ICC2. Right? Even you can use ICC2. But we are using advanced version of ICC2. This part is what? Fusion compiler. So we stopped using ICC1. So 5 to 6 years before only. Right? We are not using it. So 1 year before we were using ICC2. Now we have migrated to Fusion compiler. So the recent batches what we are using is Fusion compiler. So Fusion compiler advanced version of ICC2.
Hello.
Yes, please tell me.
Can I know the timing for the weekday schedule?
Yes, see, I'll mention, I'll come to that. So just I'll
Okay.
complete this. So PD advance, we have two things, weekdays and weekends. See, in weekdays, lab is done, right? Lab or project with help of mentor. So complete 5 days. It is from Monday to Friday. So this is done Monday to Thursday, sorry.
So the
So
method
weekend, theory is done. Theory of physical design is covered in weekend. That is Saturday and Sunday. Right? Friday will be off. And even weekend, we have one more option. Weekend lab. Right? Weekend lab is done only on Saturday and Sunday. This is only for the candidates who cannot attend on weekdays lab. So those who can attend weekdays lab, please attend on weekdays. And those who cannot attend on weekdays, please attend on weekends. That is Saturday and Sunday. So theory is common for both. Even weekdays should attend what? Theory on Saturday and Sunday. Even weekends should attend on theory on Saturday and Sunday. Morning 10 to 1, there will be a theory class. After that, weekday students will go to home or they will end the session. After that, there will be a lab for weekend candidates. For weekdays, the lab will be on weekdays, Monday to Thursday. So both should attend the theory on weekends. So morning there will be a weekend theory, afternoon there will be a lab. Lab don't attend both. Don't attend weekdays and weekend. Don't attend. So this sessions will be 3 days, 3 hours per day. It will be from generally it will be from 10 to 1. 10 a.m. to 1 p.m. Normally, if at all, we divide the batches. For example, if the strength is very huge, so previous batch, if you see the strength is 90 or 110, if strength is very huge, then we'll divide into two batches. So first batch will be from 10 to 1, second batch will be from 2 to 5, right? Like that. Even it can be in the afternoon if the strength is very huge. So we'll divide into two batches. So you have flexibility of changing the batches or which batch you want to register, that you can discuss.
Hello, sir. Sir.
This is only if the strength is very huge.
Hello.
Yes, please tell me.
Hello, sir. In the weekdays, you mentioned the time 10 a.m. to 1 p.m., right?
Yes,
From Monday to
3 hours.
Thursday. Is it a 3 hours class or a lab, sir?
Lab it is. Lab means hands-on.
Then
Mentor will work
class
and
time.
you will work
Then
along with
class.
him.
Then class timings in weekdays for weekday students.
Both. For weekdays and weekends, it is on weekend only. Weekend theory, both are going to attend, right? This is attended by weekdays and weekend. Theory is common
Okay,
for both.
okay for weekdays and the weekend students. Theory is common for only weekend. Okay.
This is both will attend
Theory.
on weekend,
Both.
Saturday and Sunday.
Okay.
That is, see why Saturday and Sunday? Because this is done by some experts who are available only on Saturday and Sunday. Right?
Sir,
And this is also 3 hours per day, and it is also from 10 to 1.
Hello, I have a
Slightly
doubt.
variation in the timing will be there. It may not start at 10 o'clock. It may start at 9:30 sometimes.
What's the time for the PD basics on weekends?
Yes, I'll come to that bit. This is lab will be 2 to 5. It's compulsory 2 to 5, right? Because it is after theory. It will not be in the morning because weekend lab students also will attend what? Weekend theory in the morning, afternoon they'll attend the lab.
Can we know the timing for the PD basics too, like on the weekdays?
So it will be 10 to 1.
The same timing, okay.
sir, what about online students? Is there any difference between timings or not?
For
For online students,
yes, the course will be conducted in both online and offline. The similar way how it is happening right now. I am attending now. Few students are attending offline who are in the classroom, and if you are attending online, right, the same way every session will go on. So there is no change in the timings for offline and online. Both will run parallelly, right? The same mentor for offline and online. So online students will attend online, offline will attend offline, and you can switch any mode. If you are interested to come to institute, you can come, or if you want to attend online, you can attend online. It's up to you. You can switch to any mode at any time.
One more question, sir. Like the lab projects you mentioned, like there will be a mentor. The mentor will be for all of the students, or like they have like different mentors for particular people.
Yes, sir. See, first I'll complete this course structure, right? I'll
Okay.
then come to your question. So
Okay.
recorded videos will be given, and even this pre-recorded videos will be given for both, right? Even for this also we give recorded videos, live recorded videos for lab as well as theory, and we also give pre-recorded videos. This will be present till your course ends, and this live recorded videos will be refreshed for every 15 days. So this live recorded videos is given only with the intention that if you miss the class by any chance, you can cope up due to some health issues or some other personal reasons. If you miss the class, so then you can cope up and you can attend the next class. You can watch the video. So for that reason, live record videos are given, so you can utilize that. So next to this, right, lab. When we come to the lab,
Sir, here pre-record videos means like that last two batches videos, sir.
pre-recorded videos, right?
Yes.
So what is your question?
Is pre-recorded videos is it's our batch recorded videos or a previous batch recorded videos or
We
separately
will
recorded
give
videos?
your batch recorded videos also, live recorded videos. We will give two videos. One is live recorded videos. Pre-recorded videos is nothing but the videos done by some expert mentors who was an earlier,
For
right?
for revision,
So
yes.
those videos also will give. This will be present till your course ends, and this will be refreshed for every 15 days. The first day video it will expire after 15 days. Second day, next 15 days. Like
So
that it
the
will be.
pre-record videos can be accessed even right up when we start the course, right? Pre-record
No, you
videos.
can access anytime you want. After starting
Okay.
the course or in the middle of the course.
No,
And even this videos will be present after course ends next 15 days or 1 month.
okay. Okay. Thank you.
See, recorded videos can be extended on request with genuine request, right? See, only thing which see we are VLSI Guru never hesitate to support the student, but only thing is it should not be misused, right? Misused in the sense is so some students will sell their recorded videos. It's only username and password. There is nothing there. If the username and password to given anyone, they can see the videos. Some are doing all these things, right? If you are not misusing it and if you have genuine reasons and if you want to extend the recorded video timing, so VLSI Guru will do without any hesitation. There is no hesitation in it, but just don't misuse the videos. If you are enrolled and you can utilize, that's it.
Hello, sir.
Yes, please tell me.
Hello. Sir, how the online students will use the tool or lab?
Yes, a tool will be installed. See, tool is whatever tool we are using is it is a VPN. Right? Even industry works with VPN, virtual private network. Means you are going
Okay,
to
sir.
connect to our server, VLSI Guru server through internet. Any student who is working offline or any student who is working online should connect to the VLSI Guru network through internet. So only the requirement is you should be having internet and you can access from anywhere. Even the guys will access from USA, right? Other countries also they'll access our to server. So our mentor will help you and they will guide you how to install this VPN on your laptops. And from that you can
Okay, sir.
access
Thank
VLSI
you.
Guru server and you can utilize the tool and you can do the projects. And tool you can use 24/7. You can use anytime you want.
Okay.
There is no restriction in that till the course ends.
Okay, sir.
And see, tool will be you cannot use the tool after course end date. Course end date plus 15 days. When the course ends, after plus 15 days, we will give 15 days time. After that, your tool usage will be done. So till that point, you can use the tool.
Is there any
Okay, sir.
time?
Thank you.
Hello.
Please tell me.
Is there any time difference to be presented for the US students, if possible?
Okay, your question is, you are from
So
USA, right?
yeah, so in India it's 10
So
a.m. to
your
1
timing
p.m.
is
right?
different. Is there any method of different
Yeah,
time,
that's what
right? That
I'm
is what.
asking. Yeah.
So I think it is very late when you attend for 2 o'clock and all. But morning you can attend, correct? Is this also late for you?
Yes, sir.
No, you can talk to the admin later or manager with manager, right? And they can make some arrangements for you.
Okay. Thank you.
You can talk to them.
Sir, what is the total strength of your institute, sir? And how many students are placed in last year?
Yes, I'll come to the placement, right?
Hello. Hello,
I'll
Srinivas.
come
Could
to
you
the
start?
placements. I'll
Hello.
complete this session structure first. Queries, I'll come to the placements next
Hello,
thing.
Srinivas.
Yes.
Could you start this structure, physical design structure? So we'll take all the questions at the end of session.
So you're asking what is the content of physical design, right?
Yes, we will start the structure, complete course structure, and then we will take the questions at the end. I'm suggesting.
No, I didn't understand.
Okay, what I'm saying, we will start the session currently. So what is a physical demo and structure? Then we will take the questions at the end.
Yes, okay. So that is fine. Because
Yes,
if few
because
students
we are almost discussing the last 20 minutes on same thing.
no problem. See, because some students will exit in between, so let them know the structure
Okay,
first.
okay, okay,
See, because when he will be knowing what is the physical design, what is content, right? I think
okay. Mhm.
they will exit. So for that reason, why will take the first structure. So many will join to the demo only to know the structure, how it is, and what tools are given. So next is placements, right? So what is placements? So placements, when I come to the placements, first I'll discuss how this placements works in VLSI Guru, right? So placements, to support the placement, we conduct tests, mock interviews, and assignments. So we'll conduct test, mock interviews, and assignments. These three things we will conduct on regular basis. Test will be done after basics once, and we'll do mock interview after basics and even after the advanced physical design. So regularly we'll do all these three things. So to know the students, to make the students aware about what type of questions are asked, right? And at last he will also make interview preparation sessions. Now currently we are doing, right? So interview preparation sessions. See, at last, when we complete advanced physical design course, at last we will do final mock interview. The candidates who are clearing final mock interview, they will be allowed to take the placements. That is a rule from VLSI Guru. Because the who candidate who cannot attend, who cannot clear our mock interview, surely will not perform in the placements, right, of the industry. So the person who is clearing our final mock interview, he will be allowed to take the placement, and obviously every student who is clearing our mock interview, he will get the job. That is for sure. The students who are not clearing the mock interview, they are not serious about their sessions, are not serious about their course journey, and obviously they will not get the placements. There is only one word I can assure with this, right? So again, when we come to the placement side, we have service-based companies, product-based companies, and we have posted the students' information outside also, outside the on the notice board. So recently, our students are placed even in product-based companies like Intel, Nvidia, Moschip, right? They are placed there, and even our students are placed in many service-based companies. Almost all the students who will clear our mock interviews, so they are placed. So they have one or two offers, not only one offer, 2 to 3 offers they have, right? That is what I can assure, I can tell. But those who are not clearing mock interview, it shows their seriousness and how they have taken the course, right? See, mock interview clearing will not only happens with attending the sessions, regular preparation. Right? Whatever is done, we have to regularly prepare for that. Nothing else we need not to prepare, right? Only whatever we do, prepare that properly. So regular preparation and with good communication skill, right? You cannot tell that I don't know English when you completed your UG, right? So I don't know how to speak in English, right? You cannot tell that. If you have that issues, then you can approach the institute. So we have some English mentoring classes. So institute will help with that, right? So if you have good communication skills and if you go through these sessions properly without any deviation, so surely you'll get the job. Not even currently students are having 1 or 2 to 3 offer letters. Now you can ask any questions on placements.
So do we get any course completion certificate after this?
Obviously, right? That will be given.
Okay.
Course completion
So
certificate will be given.
only we clear the mock interview, then only we get, or like generally get without that as well?
So you can see you can get the course completion certificate if your attendance is correct, good, right? Then you can
Okay.
get that.
Okay.
See, mock interview clearing, you don't think that we are creating this mock interview to filter the students. See, we will not get any benefits just filtering the students and keeping in the institute uh, list. Right? Mock interview is conducted just to project good candidates in the front of interviewer. So, if the interviewer, if any company comes and if they feel that okay, the good candidates are coming from VLSI Guru, that will benefit the other students because the same company will come again and again. Or else if the company feels yes the candidates who are coming from VLSI Guru are not good and they may not come back again to us, that will create a problem for us. So mock interview is done to support the students. Okay, now whatever you're answering is not the right way. The right way of answering is this way. So please answer in this way, right? This will be the better way to answer, or your communication is little bit weak, so please focus on that. So explain about yourself, right? If I ask this question, students will start telling that okay, I am living here and my family is like this and my father is like this, my mother is a housewife, right? And I will tell okay, this is no one is interested with your father and mother's data, biodata. Just explain about yourself, right? What is your current education, what is your how you are motivated to take the VLSI Guru course and what you've done in the course, what are your hobbies, and if you have any achievements in sports or any other extracurricular activities, mention that. And these are things which you should answer instead of telling the your parents or brothers history, right? You need not to be tell you need not to tell that, right? Just will guide them how to answer in mock interviews. So that is the reason why we conduct mock interviews. So mock interview we will not ask intentionally any tough questions. Right? It is the question whatever we do, the same thing we are going to ask with little bit of 1 or 2 questions will be a little bit tricky, just to test how capable you are handling tricky questions. That's it.
Sir, sir,
Yes.
will you guide us to build our resume?
Yes. So we will conduct interview preparation sessions, right? So we will forward the resumes, previous resumes, whatever we have, and you can go through those resumes and you can prepare according to that. Or if you have any doubts, we can come to the institute and you can talk to us, or in interview preparation session you can ask about that.
Sir, what is
Like
the total strength of your institute, sir?
see, we start batch once in 45 days. So obviously it will be once it will be 120, right? September, last year September, if you take the strength is 120. Next batch, if you take, it is also 120. The previous batch, which we started in January, it is 40. So now, which we started in month of December, right? What is that? It is 60. Now I don't know how much will register. So that will vary month to month. Right? If the month is on, if we are starting in month of like June, August, where your academic year ends, then it will be around 120 or 160. So it will vary batch to batch.
Sir, what is the average placements for every batch, sir? Student.
See, those who have cleared mock interview, compulsory they'll get the job. So out of 120, if 80 are clearing, they'll get the job. One batch 80 may clear, other batch 25 may clear. It's about the seriousness of the students. So those who clear the mock interview, they'll get the job for sure. So clearing mock interview and attending this test, showing their interest is important for us. And if you do all these things and if you don't get the job right, you please approach us. See, getting the job will affect you. If you do all these things, still getting the job will affect you only if there is a recession. Right? Recession happened in 2021, I think, right? So totally 6 to 7 months, there was no job at all. Not even single candidate got the job because of heavy recession. So even in that case also, we have tried our level best to place the students in the company, right? But when there is no recession, obviously you'll get the job without any doubt.
So the interviews will come through VLSI Guru, or like they have to apply by themselves?
No, no. We will see if any company, see, company will approach us, correct? They will approach all the institutes, I think. Any service-based companies or product-based companies, they have the requirements, right? They will
Yeah.
approach everywhere because companies will not take candidates from the college because they have to train them, they have to explain them what is front end, what is the back end, everything, right? They will approach all the institutes. So as we also have some MOU with some companies, right? Whenever they have requirements, obviously they will approach us. So when they approach us, based on the students who have cleared the mock interviews, we have separate group called as placement group. In the placement group, we'll post that message and we'll collect their resumes and we'll forward those resumes to the companies and companies will schedule the meeting means meeting for the interviews. So we will
So
only collect the resumes from the candidates.
okay, so that activity will be done by like institute like VLSI Guru. So we don't need to apply like students who is
No, you need not to apply. If you apply, it's your wish again. But
okay.
VLSI Guru will also collect. See, placement, if you clear mock interview, placement becomes the responsibility of the institute.
Okay, I got it. Okay. So like I have a
Sir, how
confusion.
many times
How
to
does
take?
supervisor apply?
Hello.
Sir, one more thing that you are providing material. You are providing material now. Sir, for online students, how it was like it's a document or material per year.
Yes, I'll take only last two questions. Right? Then we'll jump into the physical design thing. So please be a little bit louder with your questions.
So what is the fee
Sir, you
structure
are
of the
providing.
fee structure for
Sir, you
offline?
are providing material for
Okay,
material, sir,
what is
for
the pay
online students.
structure for the candidates who are placed? That is what your question. Fee
Sir,
structure. What is the fees, right? You are asking.
Yes, sir.
See, fees institute. How? Please contact the institute, right? I don't know what is the fees. So please contact the institute.
sir,
Institute. What is the fees? I cannot tell what is the fees. I think
sir,
they have mentioned in the brochure. They have not mentioned. The same fees will be there. Yes. Yes. Please tell me.
sir, will there be any problem with the students having gap after graduation in placement?
No. There will be no gap. No problem.
Hello.
The gap
Yes,
is good in
thank you.
VLSI, right? You can discuss with us personally. Gap is good in VLSI. See what happens is there are, see, I can tell you only one thing which I cannot tell. There are product based companies and service based companies, right? See, product based companies will
Yes, sir.
hire the candidates only with experience, with 3 to 4 years of
Okay.
experience.
Sir.
So the service based
Hello, sir.
companies, what we have, please allow me to talk 2 minutes.
Uh,
Please allow me to talk 2 minutes. Please wait. Service based companies, what we have, they
Yes, sir.
doesn't have any projects. So they will allot you to the projects of product based companies. So example of product based companies are Qualcomm, Intel, Nvidia, Google, Moschip, Samsung. These are product based companies. So service based companies will allot you to work in the product based companies. So these product based companies will hire only the candidates who are having experience, 3 to 4 years of experience. That is called as temporary employee, right? You will be a temporary employee of that company, product based company, till the project completes. So now
Okay.
you will go to that company, you will work in that. So now the service based companies, what they will do, they will also give preference to the candidates who are having year gap in between, so they can claim the experience on. There is a chance.
Oh,
And for the freshers, right, don't think that there is no opportunities for freshers. Even for freshers, there is an opportunity because there is a ODC projects. ODC means product based companies will give their entire project to service based companies. So service based company only is responsible for handling the projects. So they can allot any employees they want. At that case, what service based companies will do, they will allot more for freshers, right? Because freshers have a little bit less salary compared to what seniors, so they can get the work done with lesser cost. So there even they will hire many, because see Capgemini, other Wipro and all, right, they will hire freshers because they'll get ODCs from product based company. ODC means off the shelf projects, the right complete project they'll get, right, and they will hire the freshers also.
okay, sir. Thank you.
Okay, last question. Any question which is last?
how many chance you can do mock interview, sir?
Yes, mock interview. See, okay, I will make it very clear, right? See, placement is not restricted for you for this much amount of time, right? You can approach to the institute for
Okay,
placement
sir. Okay.
till you get the job. So you can take this mock interview whenever you are prepared. For example, this week we conduct a mock interview, and if you're not answering well, and if your mock interview is not cleared, next week if you are prepared, right, you can again approach the institute. Approaching institute means you need not to physically come here. So for every student, there is individual official WhatsApp group,
Okay,
not the
okay, sir.
WhatsApp group. See, every student will be having two groups. One is normal group. All the students will be present in one group, the complete batch. That is used only to post the timings. See, every day the same timings only, but every week our office staff will post the timings. So today the session will go on from 10 to 1. Lab sessions and weekend theory will be on at this time, right? Every week they'll post. And any information, for example, tomorrow's institute is holiday because of any festival, right? Only to post that they will use one group. Second group is individual official WhatsApp group. In individual official WhatsApp group is created for every student separately. So in that group you will be there, owner will be there, right? Along with the owner, uh, our office manager will be there, office admin will be there, and mentor will be there in that group. If you have any queries, you can post in that group, individual official WhatsApp group. Not only queries regarding technical things, even other things also, anything you can post in that group. First thing. Second thing, if you want to take mock interview again, you can post in that group. Yes, I have prepared well and I want to take mock interview again. So can you schedule me the mock interview? So they will schedule you the mock interview with any one of the mentor, and they will take the feedback in that group only. They'll not post it in the another group. Right? They'll post in the same group. Okay, this is what your feedback from the mentor, right? Or if you have cleared the mock interview, they'll post like, okay, you have cleared the mock interview. We will move you to the. We will add in you in the placement group. That is what they'll do. So you can take mock interviews n number of times when you are prepared. Yes.
Thank you, sir.
So hope I have covered almost all the questions. So if you have any other questions, right, please reserve it for the last. You can ask me at the last. Now we will. So regarding sessions and the placement, right? Please ask the questions at the last. And any technical questions, if you have, you can ask me in between. Even you can ask in the chat box. So the content, what I'm doing. So now we will go with physical design. Right? So why physical design? To understand physical design, right? Our almost all our intention, right? Let it be front end, let it be back end. The physical design comes under the category of back end. Front end means it is a RTL coding. So front end or back end, our ultimate aim is to design an IC. Right? This IC we have to design. See, if you are attending the sessions, right, you can ask the doubts in the sessions. You can unmute and you can ask, and you can ask in the WhatsApp group. And even after that, your doubts are not cleared. Still, if you have any problem, you can mention in individual official WhatsApp group. Individual official WhatsApp group is maintained for that purpose only. Post all your queries. Let it be technical queries. Technical means during the session anything is not cleared, right? It be technical queries. This I forgot to mention this, right? The session is done for all the students at a time. And if you have any doubts and if you want any support for separate mentoring session or separate session to support you, then you can post in your individual official WhatsApp group. You can mention that yes, I have few queries which was not cleared in my session. Can you support us with some mentor to clear my doubts? You can mention in individual official WhatsApp group and we will support for them. There is no doubt in that.
One last question, sir. Like, do these documents will be shared to us, like what you are right now going to explain?
Okay, see, I am not, see, whenever you join to the sessions, right, or when you are joining the course, the mentor will be in your group. The
No,
mentor
I'm
will
talking about the
ask you,
material.
but
The material
as
which you
currently
are.
I am not in, as currently
Okay.
I am not in the group, and I don't know whether any WhatsApp group is done or not for you people, right? If WhatsApp group is done, I'll ask the admin to share you, right? Or else any other means, if you want, you can ask, you can message in the uh, WhatsApp, right, to our admin, and I think he will forward you all the documents what you want.
Okay, got it. So, yeah.
Because if I was there, I will surely post you. I will surely send you. But I'm not there in the whatever groups you have, whatever groups created. I don't know whether WhatsApp group is created or not. If you can
Yeah,
personally message.
looks like it got created WhatsApp group.
Yes, you can ask personally then to the admin. They will send you.
Okay, thank you, sir.
See e-learning. See there is e-learning option also. E-learning means e-learning fees is different, right, than the live session. E-learning means you will be given the recorded videos from our expert lecturers, expert mentors, right? You will be given the recorded videos for lab as well as theory. Both recorded videos will be given to you. You can go to the recorded videos and work accordingly. If you have any queries, you can post in individual official WhatsApp group. And for every 15 days or 1 week, right? Once you can request for mentor supporting. See what they will do is if you require mentor supporting, right, they will add you to attend this, they will allow you to attend this weekend lab. Those who are undergoing e-learning, right, you will be given two videos, theory and lab. See, theory is just the same thing, right, just it is a theory part. But lab, if you want to need a support, then they will add you to this group weekend lab. You can join weekend lab and you can continue your theory lab sessions with them. Or if you cannot attend this, then you can request weekly once a support session and they will provide you. That you can mention in your individual official WhatsApp group. No, that will be, see, if you need any support, mentoring support. See, for e-learning, continuous mentor support is not given. It's only weekly once it is given. See, you have two options. One is you can attend this weekend lab regularly, whenever it's happening. Only weekend lab you can, if you're e-learning student and you can attend this lab. Or if you cannot attend this lab for any reasons, then you can get the mentor support once in a week with the mutually accepted timings. So what timing you are free and what timing mentor is free, with the mutually accepted timings, you can have a session and you can clear all your doubts. And you can even you can take the help in lab also. That they will do it. Or if you are having full of doubts, see, if you show interest, right? Institute is ready to do anything. Ultimately, Institute requires what? Institute wants you to be placed, right? If you show interest, no sir, I need a support for lab. Give me completely 10 or 20 sessions, right? To support me completely lab, right? Then we will, even the institute will do that. We have done many times. 20 sessions we have taken to support the e-learning students to do lab starting to end, right? We have done. So that is, there should be an interest from the students. So yeah, regarding placements and course structure, right? I think I have stopped taking questions, so you can ask me in the last. So physical design. When I come to the physical design, right? What is physical design? Why physical design? Right? We'll look into that. So before going to the physical design concept, so ultimate aim for every engineer to get this IC fabricated. Whatever IC we have here, this IC, this integrated chip should be fabricated. So where this IC is fabricated? Where this IC is fabricated?
Foundry. Foundry.
Yes, it is fabricated in foundry.
TSMC.
So what are the major foundries? Can you name?
TSMC.
TSMC,
Yes,
Samsung,
yes, foundry, right? Even
Samsung, Intel.
Samsung has foundry.
TSMC.
So Intel has foundry, right? Intel have their own foundries. Taiwan Semiconductor Manufacturing Corporation, that is the biggest foundry. They can produce a chip in large scale. Samsung has foundries internally. Intel has their own foundries. So what is foundry? Foundry is a place
Where chips are
where chip is
manufactured.
fabricated, right?
So now the latest chip is like Nano 5 or 3, sir? What is the like?
3 nano.
No, the companies are working from 7 to 3, right? They're working. Few companies will work on 7, few companies. Intel recent project they were working on 7. So sometimes they work on 5. They sometimes Qualcomm they're working on 3, right? So within the ranges of nodes they will work. So the lowest node is, what is the lowest node? 2
Yes,
nm. Intel has 2
2.
nm. Even they have 1.8 nm. Intel has that. So that is the lowest node what we have. So flow remains same. See, the advantage of physical design engineer is flow remains same, but the rules changes, right? Lower technology rules are different totally. So what is IC? IC is a place where chip is fabricated. See, chip fabrication is not so easy, right? It's very complicated. So chip, the IC, the foundry, whatever we are talking, it should be very neat and clean and well sophisticated, because every operation happens in IC. If you want to etch something of it, or if you want to remove any material, right, it is totally a chemical driven process. Etching will never happen by using any screwdriver or any cutting machines, right? It happens with chemical, means we are pouring some acid. The acid will remove the material. So it is, fabrication is totally a chemical driven process, and whatever transistor we are seeing, it is in nanoscale. It is in nanometer. In the scale, whatever we have, right, the lowest unit is millimeter. So if you divided millimeter into 1 lakh times, that becomes what? Micrometer. So that much small transistor we cannot even see through our eyes. We can see only through some complex microscopes. So fabrication is not so easy. So once IC is fabricated, it should never fail. Right? In the market, it should never fail. If it is failing in the market, then all the effort is lost. So they would have invested more than 100 crores, and every effort is lost. So for that reason, what we do, we engineers who are present here, we work in designing an IC, right? Design of IC. We all work in design of IC. We will not work in manufacturing IC. We work in what? Designing an IC. See, designing an IC happens through EDA tools. What is full form of EDA? Electronic Design Automation Tool. So I have given example, right? These are all EDA tools. These are the examples for EDA tools. So major vendors for IC design, right, are from Synopsys and Cadence, and we have even few tools from Mentor Graphics. So these three major vendors from where we are going to purchase our tools. So they have proven their accuracies. Right? So some places, some companies use Cadence and some companies use Synopsys. So for that reason, we have made arrangement such a way that the project is done on Synopsys, and even same thing is covered even on what? Cadence, but this with some additional cost, not more than 3,000. It will be less than 3,000. If you want to even use Cadence with the help support of Mentor, then you can pay some 3,000. You can even get these tools. So what is that? This design team ultimately, for example, design and IC is completed. So what is that we are going to send for the fabrication team? For fabrication, what we will send? So IC design is done, right, by using EDA tools, electronic design automation tools. So these are the EDA tools, right? What we will send to the IC fabrication team?
GDA2.
Yes, good, right? So we send a file called as GDS file, GDS2. GDS is nothing but what? Graphical data stream information interchange. So this is GDS2 file. So this GDS2 file will send for what? IC for fabrication. Then what GDS has?
Fabrication.
What is content of GDS? Layout of cells, right? GDS has layout of cells and its connections. That is what cells means here, gates, right? Another word which we repeatedly use for gates is what? Cells. Gates means your AND gate, NAND gate, D flip flop, mux. So layout of gates and its connections, that is called as what? GDS. That is what present in GDS. This is what is layout? This is layout, right? I don't know how many UG classes has the information about layout. So what is layout?
Connection between the cells.
No, layout is not connection between the cells. Layout is nothing but top view, right? What we see from the top view of the IC, right? That is called as what? Layout. So if you in the layout you have many layers. So what are the layers you will see in the layout? Can you tell me the layers?
So M1,
This is a
M2.
layout of what? It's a layout of inverter, right? So if you don't know what is layout, right, then that is covered in which topic? For that reason, we are doing basics, right? If you don't know what is layout, then you will be undergoing this understanding layout in which topic? CMOS basics. First, we will discuss about fabrication, then we'll discuss about of layout. Right? If I want to write the layout of inverter, so you know what is inverter, right? So inverter has what? PMOS and NMOS. So this is called as inverter. This is V in, this is V out, and this is VDD, and this is VSS. So if this NMOS, CMOS structure, if I want to write, how to write? First, I will be having P substrate. In the P substrate, I am going to form what? N well, right? Because PMOS cannot be fabricated in P substrate. So this is P substrate. This is P substrate. What is this? This is N well, right? In N well, I am going to form PMOS, PMOS source and drain. This PMOS I have, right? PMOS source and PMOS drain. So this is P plus source and drain. And here I am going to form what? N plus source and drain. This NMOS, this both are called as what? NMOS is called as what? PMOS. On top of this, you have what? You have silicon dioxide. On top of silicon dioxide, you have polysilicon. So this is the structure of your CMOS. This is gate, this is source, this is drain, gate, source and drain. So this fabrication process is discussed in what? Our CMOS basics. So then the same layout if I write for this, how do I write? For drawing the layout, first I will write the P substrate. What is this? This is a P substrate. This complete thing, right? Whatever I have, this complete thing is P substrate. Inside P substrate, what I have? N well, right? This complete is N well. After N well, right? I have this diffusion, right? This is N plus diffusion and this is N plus source and drain. N mass source and drain. This is P mass source and drain. So I will form the source and drain here, right? This is diffusion. This is diffusion. So in between diffusion, polysilicon is crossed. So here gate and gate is shorted, correct? This is gate. Gate and gate is what? Shorted. So this gate and this gate is shorted. So I can short by using polysilicon only. I can short by using this polysilicon only.
So what do you mean by short? I don't understand what short means.
Short means connect, right? We can
Oh,
connect
connect.
this by polysilicon. See, as you don't have CMOS basics, right? You will understand when we do CMOS basics. Those who doesn't have knowledge of CMOS. For that reason only we have included in the CMOS basics. So the same connection which is gate and gate is connected here also. This gate of this is gate of this transistor. This gate of what? This transistor. Both I'll what? Both I am connecting it. And now this becomes source of PMOS. This is P plus. This becomes source. This becomes drain. And again this is N plus. This becomes source and this becomes drain. So here this is source, right? And this is drain. This source is connecting to what? VDD. The source of PMOS is connecting to what? VDD. This is source of NMOS. It's connecting to what? VSS. So can make that connections. Right? So you
VDD
have
means
metal layer here. You have metal layer. This metal is nothing but VDD. This metal is nothing but VDD. And again you have metal layer here. This metal is nothing but what? VSS.
so I know VSS means ground, like VDD means what exactly it means?
VDD is power, voltage, higher voltage. The voltage may be like 1.5 volts in lower technology. VSS means ground, 0 volts.
So it only can accumulate like 1.5 volts.
Yes, that you'll understand when you go to CMOS basics, right? So for that reason only you should enroll for CMOS basics. So source is connecting to what? VDD. Make that connection. So connect source to what? VDD. So this is a metal layer. What is blue color? It's a metal layer. But what is this yellow layer? Yellow is what? Diffusion. So metal is connecting to what? Diffusion. I cannot make the connection directly, right? I should use one contact cut here for making the connection. Separate contact cut should be used when we are making this connection. Maybe I should make one contact cut. Again, this VSS should connect to what? This VSS should connect to source of NMOS. Right? Make this connection. That is what you're seeing, right? This source is connecting to what? VSS. And here again you should some contact cut should be used because this metal is connecting to what? Diffusion. So here one more connection. Your drain and drain is connecting to each other. PMOS drain and NMOS drain is connecting to each other and they are making it as what? V out. So that you have to make a connection. Connect drain and drain. Again here there should be a contact cut. Here there should be a what? Contact cut. Right? Because your metal is connecting to what? Diffusion. And here this is you are making one pin here. What is this? This is V out. And for V in, right? What is V in? The gate and gate, polysilicon and polysilicon which is connected. That is going to form what? V in. So this polysilicon which here connected, that is gate. So that we will make a connection. As this polysilicon is connecting to what? Metal layer. So again I should use what? Again I should use a contact cut here. Any semiconductor connecting to metal layer, right? I should use what? Contact cut. So this is V in. So this completes your layout. So this layout of only inverter. So similarly, you should understand how to write the layout for NAND gate. How to write the layout for what? NOR gate, XOR gate, right? So now in the reality, what happens? One gate output will connect to what? Another gate input, right? This gate output will connect to what? This gate input. Here also I should be having layout. Here also I am having layout. I am not writing it. So this gate output will connect to what? Next cell input. So this connection of layouts of gates is called as what? Is called as GDS.
Circuit.
So this is the ultimate thing what we are giving to the foundry, right? So foundry will understand only this GDS. What is GDS? Connection of layout of gates. Here also layout I have not written. Here also layout of some gates. So connecting this layout of gates is called as what? GDS. So that is what ultimately we are giving to the foundry. So foundry will understand only layout. But from where the design starts, if you want to start designing an IC, right, that is called as ASIC design flow. ASIC stands for application specific integrated circuit.
This you were saying that this will start after RTL tool extraction, or this is before that?
What? This ASIC design flow, right?
Yeah.
In ASIC design flow only you will get all those steps. That steps only is called as ASIC design flow.
So the one which RTL tool does, or like the one which PD
I'll come to
starts?
that. Wait for a few minutes. You'll understand. So what is ASIC design flow, right? ASIC design flow starts with specification. Right? Specification of IC. So what is the requirement of IC? Right? Specification of IC. So what is specification of IC? Means this IC request should have what blocks, right? Blocks in IC. What are the blocks required in IC? What is the estimated area of IC? See, we cannot assure that IC will be of this much area only, right? We can just tell, okay, IC, we can have this much estimated area of IC. Estimated power consumption. Next is clocks. What are the clock frequency for each block? What is block in IC means? These are blocks in IC, right? So one IC may have different blocks inside. If you see, these are the different blocks inside what? IC. So IC may have what? ALU, arithmetic logic unit, ASIC, graphical processing unit, control unit, PLL, right? Phase block loop, right? Like you can have different blocks in an IC. First, the specification team will decide what are the blocks in an IC. Next, what is the estimated area of IC? What is the power? What is the clocks for each block? All the blocks may not work with same clock frequency. Each block may require what? Different clock frequencies, right? Clock frequency for each block. So what is role of PLL? Phase lock loop. What is the role of PLL? PLL is used for that purpose only, right? To produce clock with different frequencies. For that purpose only PLL is used. The role of PLL is to produce the clock with what different frequencies. PLL is analog circuit. It's not a digital circuit. So clock frequency for each block. So all these things are decided in a specification. So in the specification IC architecture team who are having very good experience, they are involved, right? Because they only will be knowing what is the estimated area from the previous project experience. And if I tell, okay, I require one SOC for mobile application, if that is what vendor tells, right? Then the person should be able to decide what blocks present in a mobile application SOC. So this should include all those blocks, right? So after specification, after knowing what are the blocks required, then we will do design entry. Next is design entry. So design entry is done by using RTL coding. So we do RTL coding. RTL code means what? Using start describing the design. Design is described. for each block, right? For each block, design is described using RTL coding. RTL means, I'll directly write what is RTL. It is Verilog or VHDL.
Sorry to interrupt. Like, I want to ask for first point, like, can I ask questions or like you will only take
Yes,
at
yes, you
last?
can ask. Please ask
So,
questions.
so the estimated area for IC, you are saying that, right? Let's say the vendor will ask, like, that vendor is used in medical industry and then different line of businesses, but the chip will design for all kind of purpose. Only one, the area and everything will be one chip that will be used medical purpose, that can be used in a other, like any other purpose in the company. So I
No, no,
just want
it is not general chip, right? It is application specific. We can design a chip only for mobile application, or I can design a chip only for medical application. We cannot design. We are not designing for all the applications.
so car industries means like only chip they can
What is
use
the
only in the
purpose
car.
of application? Only for that we can design.
So that chip cannot be used for the multiple purpose.
No, that is not ASIC, right? Then ASIC name only will go, right? Application specific. It is.
Okay. So only one, like if I want to use in the car industry, so uh,
That is
they
different
only,
chip.
that is a
See,
different.
car industry, what type of blocks they want and how fast they have to. See, mobile, if at all there is a small fraction of delay, nothing is going to happen, right? So the
Yeah.
algorithms used and the style of means how to handle the internal blocks of hardware, right? Everything is different in mobile phones or ATM, whatever using, right? If there is a small delay, there is nothing going to happen, fraction of second delay. But car applications, say you have airbag system, right?
Yeah.
If there is a fraction second of delay, right? Life is gone.
Yeah, that is
So
true.
they have to be handled with utmost care, and so they have to means they have to meet the timing very hard. Right? So every electronic circuit, the designing and efforts will vary depending on their applications.
But the specification is they can decide, right? Like that design part, you are saying that the timing and all will come into design part, right? But the specification we can go, uh,
See,
but
specification is for only one IC, right? If your mobile
yeah.
phone application, what are the blocks required? That is what they're deciding.
Okay.
Now, what is your doubt? You're telling that why can't we do one IC for multiple applications, correct?
Yeah, I'm like I have that doubt, so that can be
No,
fit into
why?
design.
Why? Okay, I have one IC, right? For example, I have IC for multiple application. Why I will carry in my mobile phone simply, right? Medical application IC. Why I have to carry in my mobile phone simply to result in more area, right? If I have additional thing, I will result in more area, more power consumption. When I'm using only at once, then why I have to use in my mobile phone, right? Simply. Medical application means you're telling that medical application ICs are different. They will work for different application like MRI or whatever we have ECGs, right? So those purpose is different. And what is mobile phone application is totally different. So why those logics I should carry in mobile phone
No,
application IC? That will
no,
obviously result in more area, more power. Why we have to carry that?
my question is like estimated area for IC means that foundry will be given the only those that area
No,
can
no,
be
no.
used.
Not foundry area. Right? You will estimate what is the area, right? You will do the physical design, correct? You will
But the
decide what will be your area of the IC. Designer will decide. Foundry
oh,
will not
but
decide. Foundry will
uh,
fabricate IC according to your GDS.
but they will give like they have the rules, right? What size we can use for
Rules.
particular.
IC rule will not be there, right? See, minimum IC size will be there, or minimum
Okay,
transistor size will be there. There will be no restriction on size of IC, maximum
okay.
size of IC. So
So I
rules will be there. We have to meet the rules for foundry. Then only they can fabricate.
yeah, that is true. So I thought like the chip we can decide based on the foundry.
No, whatever chips, mobile phone application chip, you would think it is very simple, right? It's very complicated. The area will be more than the limit given by foundry. The foundry will tell, okay, minimum IC area should be this much, right?
Okay.
It should be not less than that. If it is less than that, then we cannot fabricate. That is what the rule given from foundry. But whatever ICs we are fabricating in real world for mobile phone application, Intel will work on laptop or servers or on networking chips, right? Or any Samsung will work on their applications. So those IC size is very big compared to the given from foundry limitations.
Okay.
See, mobile phone IC, we think that is only used for mobile phone applications, but that itself carries a lot of data, right? It uses transmitter, receiver, right? Audio encoding, video encoding. We have many applications in mobile phone IC. It's not very simple.
That is true.
Ethernet, it supports Ethernet, right? And other technologies, 5G, 4G, right? All those it's supporting. So it's not so simple. It's even the IC is complicated, very complicated. So design entry, right? Design entry we will do by using RTL coding, by using what? Verilog or VHDL. So why design entry is done by Verilog or VHDL? Why? Why we should start
Sir,
with Verilog or
because it
VHDL?
is
Why not directly with the circuit? Because Verilog or VHDL will allow you to describe circuits, right? Verilog or VHDL will to you allow to describe circuit based on its behavior, right? Based on its behavior rather than the internal structure. So we can describe because we have if statements, case statements, right? So rather than on its internal structure, so we can describe based on its behavior. So I give one example here. So if I ask you to describe, right, mux internal structure. I want 2:1 mux internal structure. How many can you draw internal structure? By using gates, by basic gates. You know what is 2:1 mux, right? This is I naught, this is what? I1, this is what? Select line, this is output Y. Now I am asking the question, draw the internal structure of mux by using gates, AND gates, OR gates, inverter. How many can you draw?
So we
Okay,
have
give
to
a
first just need to define about the inputs and outputs and the wires initially. Then we have to start the module and
no, I
just
was
bench.
just asking, draw the internal diagram by using gates. I don't want optimization. Means I am not asking with less gates, right? Only gates. How many can you draw? Okay, that is fine. Now I am just telling you, tell me the truth table, right? How many can you tell the truth table of this? I have select line and I have what? Output Y. If select line is 0, what is Y?
I not.
If select line is 0, what Y is going to take?
I1.
Take I naught. If select line is 1, Y is going to take what? I1. This is the behavior of mux. So how many can you remember the behavior of mux? Which one is easy? Remembering behavior is easy or internal structure is easy? Remembering behavior is easy compared to what? Internal structure. So Verilog or VHDL will allow you to write the program only by its behavior, not by its internal structure. So behavior is very easy, right? What you can do, you can just write if statement. If S is equal to 0, Y is going to take what? Y is going to take I naught. Else Y is going to take what? Y is going to take
One
I1.
one.
This is a behavior. This is a behavior by using if statement. So describing behavior of any circuit is very easy compared to describing directly into its internal structure. So you assume if you have complex design, directly if I ask you to write the internal structure, you cannot write D flip flop, right? I will give one more, we will take one more example, that is D flip flop. How many can you tell the write the internal structure of D flip flop by using gates? You have D flip flop, you have clock, You assume you have reset. You have Q and you have what? Q bar. How many can you write? Internal structure. But behavior you can clearly write, right? Is a behavior. If reset is 1, so whatever the value of clock, if reset is 1, whatever the value of clock, you are not worried. Your output Q will become what? 0. If reset is 0, at the positive edge of clock, Q is going to take what? Q is going to take value on D. If D is 0, Q is 0. If D is 1, Q is going to take what? D. This is the behavior of D flip-flop. If I tell write the Verilog program, I can easily write. Right? If reset is equal to 1, Q will become what? Q will automatically become 0.
Yeah.
Else, Q is going to take what? Q is going to take D.
D.
This is the behavior of D flip-flop. You can, at least if you are not remembering, you know now, at least next week you can tell this. But how many can you remember the internal diagram of D flip-flop by using gates? Right? So remembering internal structure is difficult, but remembering the behavior is easy. So Verilog or VHDL is allowing you to describe the circuit based on its behavior, not based on the structure. You can easily describe the behavior of circuit. That is what the advantage of writing by using what? Verilog or VHDL. So after writing the code by using Verilog or VHDL, design is in what form? Design is in behavioral form, right? Design is in what form? Behavioral form.
So what structure it is there in the circuit, sir? So it is in I'm a bit confused. Like if you open the any circuit, what kind of diagrams we see?
This D flip flop, right?
So we only see the D flip flop, and then inverter means just like that symbol.
No, I am asking. I am not understanding your doubt. What is your doubt?
So if you open the circuit, any circuit IC, so what structure we see, like this D flip flop or any inverter we see directly inverter, or like previously you were showing like.
You will see the layout. You will not see any gates, right? This layout you will see. Layout of cell or not layout, layers you will see.
So this is the
You
one
see
we
not
see.
layout. Layers, you will not see layout. Layout is just a understanding form. It's in the EDA tool. You will see the layers. You will see
Okay.
diffusion. You will see. So this is going to form one gate, right? And one gate will connect to another gate by using metal layer. So this is what you're going to see in
So this
IC.
is the one we see in IC.
Yes. We are not doing IC
Sir,
here,
for
right? Here
physical
we are
design,
into
must
starting.
and should need Verilog, sir, or not?
Yes, please repeat once again.
For physical design, we need Verilog or no need?
Not required physical design. This is a starting stage of IC, right? I have never told this is a physical design flow. It's a starting stage of IC design. So first is
Yeah,
we are entering to the IC by writing Verilog or VHDL code. But this Verilog or VHDL code we cannot give to Foundry, right? What we should give to Foundry? For Foundry,
indeed, sir.
we should give this layout.
Layout of
This
layer.
layout only Foundry can fabricate. But design entry we are doing through what? Verilog or VHDL. In Verilog or VHDL, we are describing any circuit through what? Through behavioral description. Now, next, so after this, we have one more step called as functional verification.
Excuse me, sir.
Tell me.
Sir, as we have different styles to write Verilog code, sir, as we have data flow, behavioral, and the hierarchical, I think so. So, what we are preferred to write the code in the industry, sir?
See, it can be, see, data flow is only for simple circuits, right? You cannot write for bigger circuits. Data flow is nothing but only the Boolean equations you can write. How this Boolean equation is writing, right? If you want to implement on simple circuit like this, if you have AND gate, so output of AND gate is connecting to one OR gate and it's connecting to inverter, right? If you have this type of circuit, then you can write it is A and B. It is odd with what? It is AB, right? A, B, C. A and B are with what? C. And total it is what? NOT gate. So you can write for simple circuits You can go with what? Data flow. If you want to describe a bigger circuits, then you will go with behavioral. And if you want to connect the blocks, right? You have written the program for one Verilog program for this block, and one Verilog program for this block, one Verilog program for this block, and all the Verilog program we want to connect each other, right? Then you will go with hierarchical. So all the styles are used, but most used is for every block, for designing every block. We will write separate Verilog code for GPU. We will write separate Verilog code for ALU. We will write separate Verilog code for ASIC. We will write by using behavior only.
Okay, sir.
But while integrating,
So,
it will be hierarchical. Integrating means connecting all the Verilog codes. It will become hierarchical. So in between one or two lines, we may also use data flow. Very simple lines. For example, I have written some behavioral circuit. For this, yes, please listen. Later we can discuss, right? So for D flip-flop, I have written the behavioral description, and output of Q is connecting to one NOT gate and it's connecting to one NAND gate. So now what I can do after writing this, I can tell after this ending this, then I can mention what happens. This is nothing but Y. Using this is Y. What is Y? Y is nothing but what? It is this you assume it is Q bar, right? So I can tell Q and with what? Q bar, both are ANDed, Q and Q bar. Next you assume this is nothing but some Z, right? Again it is ANDed with what? Again this is ANDed with Z, that is nothing but your Y. So here small logic, if you want to implement, then you can write some small data flow also in between. So majority of code will be behavioral. Here and there they can also use data flow also. So data flow is only to
okay,
implement
sir.
small things.
And sir, you have discussed about Verilog and VSDL. Uh, as I know, sir, VSDL is a outdated one, and in industry we are using some Verilog and system Verilog or UVM. So, what are your thinking about that, sir?
Now I'll come to that. Wait. For functional verification, right? So what is functional verification? Verifying functionality of design, right? Functionality of design. So you want to verify functionality of design by applying test cases. By applying test cases. What is test cases? Test cases means apply this, right? For input, you apply inputs for this. For example, we have this mux, right? For mux, I'll apply input. What are the inputs I have? I have select line, I0, I1, Y. If all are 0, what is my Y? If select line is 0, my Y is going to take what? I0. What is an I0? 0. If I have 1, 0, 1, if select line is 1, my Y is going to take what? Value on I1. What is I1? Logic 1 is 1. So this entire input what I am applying, this is called as what? Test case. For this set of input what I have applied, for that what output I am getting, we will verify whether the output is an intended output or not, correct output or not. If it is a correct output, then whatever circuit I have written here, whatever whatever Verilog code I have written here or VHDL code I have written here, that is correct. Or if I am getting wrong output, then I have to revisit my this Verilog code, I have to modify and I have to come back again, right? So what is functional verification? Verifying functionality of design by applying what? Test cases. So this is called as one test case. This is second test case, right? Set of input. Again, third test case. For each test case, you verify what is the output. So if you're getting correct output, then there is no problem in Verilog or VHDL. If you're getting wrong output, then there is a problem, right? Then revisit it. But to do this functional verification, this is not physical design, right? This steps in ASIC design flow. Here you can become one engineer, that is RTL coding engineer. Your role is to write the Verilog or VHDL code for the circuits. Function verification engineer is to verify this Verilog or VHDL, whether they are going to implement proper functionality or not, by creating different test cases. So here you want to learn system Verilog and UVM, universal verification methodology. Apart from Verilog or VHDL, you should be knowing Verilog or VHDL. Apart from that, you should be knowing system Verilog and UVM. So then only you can do, because see, whatever example I have given, it's very simple example. It is for simple circuit called as what? MUX. To verify the bigger circuits, you should be knowing this both, system Verilog and UVM. So this is a second domain where you can get the jobs. Though this demo is done yesterday, right? From VLSI Guru, we have done the demo yesterday. Okay, now you can ask. Some student was asking some doubt on UVM, right? You can ask what is your doubt.
Yes, sir. I have understand what you are saying, that for function verification, you have to understand about system Verilog and UVM
Yes.
in
But if
depth.
you want to become RTL coding engineer, then you should be knowing very good Verilog, VHDL, and some protocols. What is Ethernet protocol? What is SPI protocol? What is I2C communication protocol? And how to implement this protocol by using Verilog or VHDL. That talent you should be having. And in functional verification engineer, you should be knowing those protocols. Apart from that, you should be knowing how to test them, how to come up with a good test cases. Test cases means how to come up with different inputs so that I can test entire design. So that those things are required by functional verification engineer. So these things are different domains again where you get the jobs. Those are separate courses in ASIC design flow. So this RTL engineer is different, verification engineer is different.
So once the design is done, like it comes from functionally verified, and then it goes to physical design, like other where they can do like timing and all these things. So they will fail in the physical design, like once they done all these verifications.
Yes, timing may fail, right? So from physical design to RTL, hand checking happens many times. So I am having many logic depth. I am failing in timing. Right? There I am seeing huge logic depth. So please correct it. Again they will correct, and again they will send. Right? Hand checking happens many times. Even they may fail in physical design. Answer there.
But
Failing means
functional.
it's not in terms of functionality. Timing. Right? Timing is different. Timing means your design should work with the clock frequency, whatever clock frequency you are using, right? 1 gigahertz clock. Your design should work. So you are testing in timing. If it is not working, then you have to tell your RTL engineer, right? Come up with a simpler logic depth between two gates. So that you'll understand when we do STA. There is a meaning. So there is a chance
So
that it may fail.
so the functional verification is only based on that will not meet
Just
any
function.
time.
Whether this is see, I can tell that this mux will work. This mux inputs are working properly, right? This D flip flops, whatever input I'll get, I'm getting output properly. But whether I cannot assure that if this D flip flop will work with the clock frequency of 1 gigahertz. If I give 100 megahertz clock, this functionality is implemented. That is okay. But if I give 1 gigahertz clock, whether this D flip flop will work, that is not tested in function verification. Right? Function verification will test, okay, this design, whatever we have, it is implementing the proper functionality or not. But whether that design will work with proper clock frequency, that is tested in physical design. They will not test here.
Okay, but they were not aware like what clock time they are doing in physical design, like while they are implementing this thing in design.
So there is no delay, right? Delay is not taken care here. There is no cell delay. So how do
No,
you
no.
tell that this design is not working with the clock frequency? There should be cell delay, right? So during functional verification, they will not take care about cell delay. They'll assume that there is zero cell delay, or there is no delay, there is no cell at all, right? Here. So
Yeah,
they
that is.
cannot pick a strategy.
No, but you're saying that like clock timing is there at what frequency will
That you'll understand it, because see, when you doesn't know what is how to validate this design is working with proper timing or not.
so the
See,
only
I'll
only
give
the
you an
failure.
example. If you have 1 gigahertz clock. This is 1 gigahertz clock. When this positive edge comes, right? Whatever data present here, this should go to queue before next edge, right? Before next edge comes, because at the next edge, this DV clock will capture next data, correct? Within this
Yes.
small time, this data should go to the output side. So in between, you have gates. So what is the delay of this gate? They are not aware, right? These gates are formed only when I do synthesis. Now they are not knowing what gates this they will form, right? So they cannot validate that whether this design will work for this clock frequency or not. Now they can only tell if my input is 0, when clock is positive edge of clock is coming, it will go to the output. 0 is going to the output. Only they can verify that. But whether it will go within one clock cycle, they cannot assure. That is assured only after this program is converted to the gate level. So it happens only in synthesis, right?
Okay, okay, I got it.
Yes, you understood what I told.
Yeah, I understand that. So I thought like the functional verification they do all those kind of things like just to minimal meet of timing as well, but looks like that is only happen at synthesis level, clock to
No,
synthesis.
where there is a timing to see, timing means there should be a cell delay, correct? So where is
Yeah,
the cell here?
yeah.
Design
Usually
is
we don't.
pure. Design is not there in the gate level. Gate level
So
happens only during the synthesis stage.
cell means you're talking about physical cell, right?
Physical cell gates.
Yeah, gets real.
So where is the cell here? The design is in the BRL form, right?
Yes,
In this
that is correct.
BRL form it is. So they cannot validate the timing now. So next is synthesis. So what is synthesis? Can anyone tell me what is synthesis?
Executing a program.
Sir, RTL to gate level
Converting
netlist.
converting RTL to gate level netlist. That is called a synthesis. You have to convert this RTL to what? Gate level netlist. Means whatever RTL we have that is in behavioral level, now convert to what? Gate level. Because behavioral level my foundry cannot understand. See, please don't ask any doubts apart from technical, right? If you want, if you have any other things, please ask after the session. I clearly told record video will be given. So this record video will be given to you if you ask, for sure, because it will deviate from the topics. This will be given. Right? The contact, right? It will be given. So converting RTL to gate level netlist, right? Means RTL behavioral description what we have that is converted to what level? Gate level form. So what are the inputs required to convert to RTL to gate level? Just a brief you can tell. What are the inputs required? So one is your RTL, right? RTL is in what form? It is in dot V or VHD. Dot V means it is in Verilog. Dot VHD means it is in VHDL. So one is here. This is nothing but your RTL code in behavioral form, right? So next, what is second input? See, you have to convert this RTL to gate level. So what gates you can use for conversion, right? Whether you can use AND gate, whether you can use NOR gate, whether you can use MUX, whether you can use D flip flop. So someone has to give this information, right, for the tool. Ultimately, what gate you should convert. So that gate level information is given in a form of called as library file. So you have library file. Library file is also called as liberty file. So liberty file, it is the extension is .lib. The files have extension called as .lib. So it has timing and power information of standard cells. So ultimately, I can convert RTL to gate level by only picking the cells from which file? Library file or liberty file. I cannot use whatever cells I want, or my tool cannot use. You should only pick the cells from which file? Library file or liberty file, which we are giving as input. This has timing and power information of standard cells. Power timing means what? Delay of cell. How much delay a cell is taking. So timing, another name for timing is delay of cell. Power means how much power the cell is consuming. A static power and a switching power, short circuit power. Dynamic as short circuit and switching. That will come on, so that will study under the category of CMOS. So all timing and power information of standard cells is present in liberty file. Then what do you mean by standard cell here? So who will give this file? This file is given from a team called as library characterization team. This library characterization team will draw the schematic of all the circuits, schematic of AND gate, schematic of NAND gate, schematic of OR gate. They will draw and they will get what is the cell delay and they'll get what is the power consumption and they'll give in a file called as what? Liberty file. Now I'm telling standard cells. So what may be the standard cells? So standard cells are the cells like
Macros.
no, not macros. It is OR gate, NAND gate, NOR gate, XOR gate, inverter, a buffer, your D flip flop, your mux, one thing and I have missed it, and so for all these gates, right? For all these gates, you will get what information? What is a cell delay and what is a power, and we also have functionality, right? Power and functionality of standard cells. Functionality means what? This inverter will do what? Not of its input. Whatever input we give, it will do the not operation. And what it will do? It will do and of two inputs. So functionality information. So this information is present in liberty file. So in our advanced physical design, we'll open this file and we'll check what are the content in detail. Right. So what is the third input of this file? SDC, right? Synopsis design constraints file. Synopsis, some will call it as standard design constraints file, but it is synopsis design constraints file. Means we'll give timing constraint, means my design should work with this clock frequency. Mainly we'll give what? Clock frequency. Clock frequency, or I can call clock period. So this design should work with this clock period. Within this clock period, the design should work. So that is called as SDC, synopsis design. See, we have many commands in SDC, not only this input, we have given many inputs. But if I tell you also not understand now, for that STA is required, static timing analysis has to be done. So now for the time being, you can understand that what is a clock period. So these three inputs are main to do synthesis. So what is output of synthesis? So gate level design, right? This RTL, which is in the BRL form, it will convert into what? Gate level design. Your tool will convert synthesis tool. Synthesis tool for doing from synopsis is DC design compiler and from cadence it is what? Genus. Even Fusion compiler can do synthesis. Fusion compiler will do both synthesis and physical design. But if you want to do only synthesis, then it is DC from Synopsys. The full form is design compiler, and from the cadence it is genus. So this tool will do. So for that, this input is required. Right? RTL, library file, and SDC. What is the output of synthesis? So output of synthesis is gate level netlist. So gate level netlist is nothing but gate level information. Right? So what is netlist? Netlist is also a Verilog program. Right? It is also a Verilog program. It is also a .v or .vhd. Then what is difference between RTL and gate level netlist? RTL is in the behavioral form, right? RTL can use if statements of Verilog. It can use case statements. It can use procedural blocks. It can use assign statements. But gate level netlist should have only gate and its connections. Gate and its connections. Only that is present in gate level netlist. I'm not telling layout level. It's only gate and its connections. So just I can give you one example here. For example, you take this design, just take one simple design, and this simple design, it is converted to this gate, one AND gate, one AND gate, and it's converted to one OR gate. And at the output side, I have one inverter. This is what the gate level diagram you got after synthesis, right? Here the inputs are M, N, O. Here output is Y or MNOP, right? So these are the gates I have picked from where? I have picked from library file. I cannot pick from any outside. It should be present inside the library file. Then only I can use that. Right? And this gate name inside the library file is AND2. What is the name? AND2. AND2 indicates two input AND gate. So this is OR2. Two input OR gate. So name of this cell is inverter INV in the library file. And this input is this pin, right? I'll call this. See, input and output of cell. Gate is called as cell, right? Input and output of cell is called as pins. Input and output of this block, this complete design is called as ports. So here M, N, O is called as what? Ports, because it's input and output of entire design. But input and output of one cell, A, B, and Y, right? This is called as what? Pins. So here A, B, Y. This is A, B. This is net N1. This is net N2. So if I write a Verilog code for this gate level netlist, right? I'm writing gate level netlist. How it will be? So you can use the keyword. Verilog will start with the keyword called as what? Module, and it should give one module name. Module name can be any name. So I will use module name as what? Temp. Some name I'll use. Then I should first declare what is the input and output of my design. What are the inputs? M and O. What is the output? P. First I'll declare that M, comma N, comma O, and P. Next I should mention what are the inputs here. What are the inputs here? Input is M, comma N, comma O. What is the output? Output is P. After inputs and outputs, in between I also have nets. This N1 and N2 is what? Nets. It's an intermediate signal. It is not the input nor the output. It's used to connect one cell to another cell. So that I have to declare it as wire. Yes, any student, one student was asking something, right? You can tell me, online students.
No, I'm trying to understand, like, this is entire you are talking about IC. This is just okay, one block.
One block inside an IC.
Okay, just
This can be seen. No one will fabricate the small IC. What is the benefit of that? But IC will be having crores of cells. But I cannot explain with crores of cells, right? Just while doing explanation, we will only explain with simple cells, 3 to 4 cells. But
so
IC
we,
like this, you can imagine connection between crores of cells.
so we need to write like this kind of logic for module temp and then input and output for each block like this, or like you write for entire. I'm trying to understand, like.
See, you will be having block level design, right? You will not be, you will be having one block. This block you will be having separate Verilog code. So whatever temp I have written here, this will be there for one block. This will be there for another block. Separate Verilog program for this block. Separate Verilog program for this block. Separate Verilog program for this block. Separate Verilog program for ALU. All these Verilog programs are integrated. Integrated means there is a RTL integration. There is a method for that will be integrated to form what full chip. So for that, we should be knowing RTL integration, but it is not our scope of discussion because that is a front end. So Verilog program will be different for different blocks. And
So, but
entire
it will
thing is integrated to
what,
form.
so once it is connected to other RTL, like other Virla or like other block, then do they have issues? It is working in a current block, but when it is connected to other block, then
No
what
issues, right?
happens?
What see it is nothing will happen. They will connect. It's okay. Bluetooth is connecting to ALU, right? What output of Bluetooth? What pin output of Bluetooth should connect to ALU? They will take and they'll connect accordingly. So they
Okay,
will
so
test in functional verification. They'll test the same thing, right? So we
okay,
have
that's
given
all.
examples. So if I tell Bluetooth protocol, you will not understand without that. So for that reason, I have told what is functional verification with simple words. But they will test for the bigger designs. They will not test simply for one mux.
Okay, so the functional team already tested all this input output, but we are like trying to do like block level whether it is meeting their timings while coming from input to output. That's what we'll do, like each block level.
We will do means who will do?
Uh,
Whom you are talking? We means
physical design
physical
team.
design. I'll discuss, right? We are not doing that. See, physical design.
Okay.
You thinking we will do. We will not do only timing, right? Apart from timing, we have many issues. Timing is totally different for physical design and front end. So we will do static timing analysis. Front end will also do timing analysis. That is dynamic analysis. So it is not covered here, right? That is separately they will do again. That is dynamic analysis. But in functional verification, they cannot do timing analysis because there is no gates. So in physical design only we can do timing analysis, but we will not only do timing, we will do many other things. So I have not come to that point, right? You please wait till that. So now what I am discussing here is what is gate level netlist. So for each block, I'll get gate level netlist and they are integrated. Right? I think in your UG classes, if you are aware, you have written parallel ladder by using what? Whether you written this program in UG classes parallel ladder by using full ladder or 8 is to 1 mux by using what? 4 is to 1 mux. So 4 is to 1 mux, you imagine that is one block. How it is connected 8 is to 1 mux. In similar way, they will connect all these blocks. So all these blocks are connected. There is a separate Verilog program for VOSB, separate Verilog program for ALU, and they are connected in between. So a Verilog program will connect in, that is called as RTL integration. RTL integration team will connect everything. But I cannot explain with this bigger program, but we can explain what is netlist only with what? Simpler program. So inside this ALU, Verilog program, the same type of structure will be there. But instead of 3 cells, you will be seeing what? Latched together cells. Only inside ALU. Inside GPU, you will see latched together cells. Inside control unit, you will see what? Latched together cells. But I cannot write the netlist for latched together cells. We are writing only considering what? 3 cells, how the netlist looks. So you can scale that. 3 cells you can scale to latched together cells.
Okay, I understand. Yeah, I just want to understand like what is the outcome of this one, whether it is like completely you're explaining, or like just a part to understand us?
No, this is you see we are scaling down that, right? This ALU itself, if I see the netlist of ALU, this ALU will be having lakhs together cells, 3 lakhs, 4 lakh cells. But I cannot write the netlist for 4 lakh cells, right? So I am writing for only 3 cells.
I understand. Yeah, now I got it.
Yeah. So now this AND gate, whatever we have. So what is netlist? What is netlist? I'm not writing Verilog program RTL. I'm writing what is netlist. Netlist is also a Verilog program. I've written here, right? After synthesis, we'll get what? Gate level netlist. It is also a Verilog program. It is having gate and its connections. For every block, we have netlist, and every netlist is interconnected. They are connected through main module. Right? It's interconnected. So now, first we'll write for this module, then we'll see how it is interconnected also, how we can interconnect it. So now, AND gate, right? This first AND gate, I had to initialize this first AND gate. So what is AND gate name? In library it is AND 2. What is my synthesis tool will give one instance name. Some dummy name it will give, like U1. So this name is given for every cell. This name is different for different cell. Because in the design, I can have hundreds of AND gates. From one AND gate to another AND gate, I should be having some difference. So that is done by this instance name, right? This instance name is given by synthesis tool. For this cell, it is given as U1. For this cell, it is what? U2. For this cell, it is U3. Some dummy name it will give. So first is the library cell name. Next is instance name. This is given by synthesis tool. Next is port mapping. Port mapping means this A pin. Dot A means A pin of this AND gate. Where it is connecting? Connecting to port M. Done. Comma. Dot B. This B pin of AND gate, where it is connecting it? Connecting where? Connecting to N. Port N. Comma. Dot Y. So Y pin of this AND gate connecting where? It connecting to N1 net. So one cell done. Right? For cell, I'm just mentioning where it's connecting. A pin is connecting to port M, B pin is connecting to what? Port N, and Y is connecting to net N1. Next, second gate. Now you can tell me what will be the second gate. What I should write here? R2 means OR gate 2 input. Next, instance name. Instance name is U2. Next, dot A.
But you're connected to N1.
A is connecting to N1. B is connecting to O. Y is connecting to N2. Next, right? What is the third gate? Inverter, right? Third gate is inverter. So inverter, highlight what? U3. So dot A, where A is connecting? A is connecting to what? N2.
N2.
And B is connecting to output port Y, P, sorry. Dot B is connecting to P, then end module. So only this should be the content of gate level netlist. It should be having gate and its connections. So you should not see any other thing. Not if statement, right? You should not be seeing. So there should be no if statement. There should be no case statements. There should be no assign statements. Only should see gate description and its connections, right? So here you can see the connection. So output of AND gate is output pin of AND gate is connecting to what net? N1 net, right? This is connecting to N1 net, and input pin of OR gate is connecting to what net? N1 net. Then it clearly indicates that output of AND gate is connecting to what? Input of OR gate. This clearly indicates, because output pin is connecting to N1 net and input pin of OR gate is connecting to N1 net. This clearly indicates there is a connection between what? Output of AND gate to input of OR gate. And similarly here also, right? Output of OR gate is connecting to N2 net, but input of inverter is connecting to what? N2 net. Then this clearly indicates that output of OR gate is connecting to what? Input of inverter. So this is a netlist of one block in an IC, right? Similarly, you will be having netlist of another block. For example, you have one more netlist for one more block. That also has two cells. Just for simplicity, I'll take two cells, but generally you will be having plenty of cells. Right? This is another cell. So what will be the netlist here? So you will be having, this is M N O P Q R S, right? And this is A B Y. This is A and Y. This is called as N1. This is AND 2. This is what? Inverter. So if I write this thing, what I will be seeing? Module. Temp. This is temp 1. I will call. This is what? Temp 2. So what are the inputs? Q R S. What is input here? Input is Q and R, and output is S. So first cell. What is the first cell I have? So what is the wire? Intermediate wire is what? N1. And so here first netlist is done. First block netlist. Now I am writing what? Second block netlist. Second block netlist. First block name is what? Temp 1. Second block name is what? Temp 2. So what is the first gate you have? AND 2. Instance name I'll call it as U3. This is U3 is already done, right? U4, and this is what? U5. This is U4. And what is the instance name? Dot A is connecting to what? Q, and dot B is connecting to what? R, and dot Y is connecting to N1 net. Next you have one inverter. Inverter, what is the instance name? U5 dot A connecting to where? This A is connecting to what net? N1 net. And dot Y, this Y pin is connecting to which port? S port. Dot Y is connecting to S port. Done. So this is the second block. So for example, I assume that in my chip only I have two blocks. Generally you will not be having two blocks, but you will be having what? Plenty of blocks like this. But generally now I will assume that I have only two blocks. So output of this block is connecting to what? Input of this block. And this output, right? This is connecting to logic 1. Just we'll assume that this is connecting to what? Logic 1. Simply we'll assume, right? So now I have to connect output of this block to what? Input of this block. So I will be having another program here. Module top. What is this? Top. So top module will be having its own inputs, right? This inputs I'll call it as A, B, and C. This is a complete chip input. This is a complete chip output. This complete chip output I'll call it as Y. Right? So what is the complete chip input? Complete chip input is what? A, B, C, and what is the output? Y. Again I will call inputs. What are inputs here? A, B, C. What is outputs?
Y.
Output is what? Y. Input is A, B, C. What is output? Output is Y. Now I have to write the program for not integrating the cells. Now I have to write the program for integrating the blocks. So this is the integration. This is how it is interpreted. So inputs of this chip is directly connecting to what? This block inputs. What are the output I am getting from first block is going to what? Second block. So second block, this is this I assume it as N1 net, right? I'll call N1 net N1. Now first, what is this top module is made up of what? Two blocks. What is the first block name? Temp1. Temp1. Some instance name I should give. Instance name is what? I'll give some instance name as T1. Some instance name. So temp block has what inputs? M, N and O. For M, what is connecting? M is connecting to what? A port. Comma. N is connecting to what? B. Comma. This O is connecting to what? C. So dot of O is connecting to what? C. And we have one more thing, right? Output of this block. Output of this block is what? P. So this P, where P is connecting? P is connecting to net N1. So this output full chip is formed by what? First block. First block inputs and outputs have written. What is inside the first block? It is present here. It's formed by using what gates?
So I have a question, like the O is connected to C means in temp 1. O
This
is
O
connected.
port, right? This is O port is connecting to C. O port of block 1 is connecting to output top level C.
Okay. So that's one. Okay.
Next, I have to define for second block. What is second block? This is temp 1, right? Second block name is what? Temp 2. What is the instance name? T2. So temp block is having what input? One input is this is Q, right? Dot Q. Where it is connecting? Q is connecting to what? Net N1. Next, what is next thing? R. Where R is connecting? R is connecting to one tick binary 1, right? It's connecting to logic 1, correct? This R is connecting to logic 1. Simplicity I have taken. It can connect to some other block output. Now simplicity I have taken is connecting to one tick binary 1. So where this S is connecting, this temp to what? Where S is connecting, dot S. It's connecting to what? Logic Y. End module, right? This is called as netlist. So this top module netlist means this is the top module netlist. How these blocks are connected, right? You will be having the program like this. In this top module netlist, you are describing what? This temp 1 block and temp 2 block, how they are interconnected. So output of temp 1 block is N1. That is input to what? Temp 2 block. For which pin? Q port. Output of this, it is coming here. And what is present inside the temp 1? There is a separate program here. What cells are present inside temp 1? What cells are present inside temp 2? There is a separate program here. So this program is for this module top is for integrating this block 1 and block 2. So just I have taken 2 blocks, but in reality you will be having hundreds of blocks. I cannot write for hundreds of blocks. You can scale up to hundreds of blocks. How it will be connected? I have taken one block is having only 2 inputs, 3 inputs and 1 output. It may have hundreds of inputs and hundreds of outputs. That is how the netlist will be, right? So each block, inside each block, what I can see, each block Verilog program netlist, I can see cells, right? These cells are present in where? Present in the library, what we have given, this library. And all these blocks are interconnected, right? All these blocks are what? Interconnected. They are interconnected like this. I have given the Verilog program for that. Temp 1 and temp 2 are interconnected. So output of temp 1, that is temp 1 block is having P port. Output of P port is connecting to what? Input of temp 2, which port? Q port. So output is N1 net. That same N1 net is connecting to what? Q port. Right? So this is how the blocks are interconnected. So this is called as netlist. So netlist should have only gates and its connections. No other statements are allowed, like assign statements, if statements, case statements. Nothing is allowed. Only interconnection between cells or interconnection between blocks is allowed. Right. So this is about your netlist that you will get after synthesis. So after synthesis, we are at what stage? After synthesis, we are at what state?
Tour
Now my
planning.
entire design, which was in the behavioral form, which we started in the behavioral form. Now we have converted to what form? Gate level form. Now I
Level.
can see gates here, right? Now, role of PD engineer. What is role of PD engineer? Physical design engineer. Physical design. Convert this gate level form to the layout form, because ultimately Foundry can understand only what form we already discussed. Right? Foundry can understand only GDS. What is GDS? Layout of cells and its connections. Right? Convert this gate level form to the layout form. That is the role of what? Physical design engineer. So what is physical design? Converting logical design. Logical design means it is gate level design is called as logical design to physical layout form. We have to convert that. That is the role of physical design engineers. So we'll take a break for 10 minutes. Now the time is 12 o'clock. We'll take a break till 12:10. So next we'll see what are the steps in synthesis. Sorry, what are steps in physical design and what is our course content. Right. We'll see in after break. 12:10 we'll come back. See, earlier when I started the class, the count was around. We'll take a
This
break for 10 minutes.
conference will
Then
now be recorded.
Don't have anything. Everyone is running. No one is able to walk there. Everyone is running. You go. Start.
Yes, we'll continue now. So, yes, whether it's audible online.
Yes.
Sir.
So, what we cover in physical design, right? See, physical design first starts with partitioning. Partitioning means see, we cannot do physical design for entire chip at once, right? Because chips has many blocks inside, and each blocks is having almost 5 to 6 lakhs of cells. So entire chip will account for almost crores of cells. So we cannot do physical design directly for crores of cells. So what we do, we will partitioning is nothing but divide chips into blocks, right? So we have entire chip that is divided to blocks, right? Block means it is not a area division. So first they will decide like what is the total chip area by this cell area, and based on that, for each module, for example, for temp 1 module, how much area we want, right? This much area we want. For temp 2 module, right? I want this much area. This area I want. So this much area I want. So there is some other module, temp 3 module. This requires this much area. So there is another module, temp 4 module, right? That requires this much area. Like this they will assign the area for each block. So this is our top module. Top module is for chip. This for different blocks. This is block 1, block 2, block 3, block 4. Within these blocks, you have cells. You can mute yourself, right? If you don't have any questions. If you have questions, you can unmute.
It's hard.
So block 1, block 2, block 3, block 4, right? This is block 1. These are the blocks. For each Verilog code, I have given example here, right? For each Verilog code, whatever we have, temp1, temp2, right? For this temp1 will become one block, temp2 become one block based on the cells, how many cells it has, based on the cell area. So they'll allot the size for each block. So this is called as partitioning.
Sir,
Partition.
I have a question. Yeah, once it's done, I'll ask.
Tell me.
So that the one which you show that dot A, those synthesis, after synthesis we get like gate level design, right? So that will be automatically converted in synthesis, or like this has to be how do we get this design? Like this is
It's
automatically
automatically done by the tool.
automatically done by that. No need someone manually don't do these kind of things.
Even this calculating and doing the area also tool will do. You will just guide the tool.
Okay, but
Partitioning just you have to do, right? Block 1, you want this much area. Block 2, right? Just okay. Block 2, if I assign this much area to block 2, then where to accommodate block 3? I have to accommodate block 3 here means block 2 I should go with this shape, right? You should just guide the tool. Okay, let it be block 2, let it be in the inverted L shape. You should just trim the tool. Okay, let it be in the inverted L shape. Block 3 I will fit here. So tool will help you. So tool will do all these things. This also tool will do. This also tool will do. So to just guide the tool.
Okay.
Now we will do next is after partitioning. Right? Partitioning is nothing but divide chips into blocks. Now when you know what is your block area, how much area you have per block, then you will do block level physical design first. Right? All the engineers who will join the company, they will work on the block level. They not work on the top level, full chip level. So you will work on the block level physical design. Right? So first you will start with block level physical design. So you will do physical design for your block. The other person will do physical design for his block. So each engineer will be given each block. So they will do physical design for their blocks, right? So next step is block level physical design. So once block level physical design is done, take all the blocks, make the connections like this, right? Here what happens? Temp 1 and temp 2 are connecting through which layer? N1, right? So now make a connection. Make a connection here means you should, this is temp 1 and this is temp 2. Here making a connection means connecting through what? Metal layer, right? Like this. So take all the blocks, connect through metal layers, block level connections you do. Then this you can send for physical fabrication. But we should do block level physical design. Right? For block level physical design, we have steps. Steps are like this: floor planning, floor planning. Next is placement. Next is CTS, routing, and next is sign off checks. So these are steps we have. So what is floor planning? Right? Floor planning is
So before jumping into this one, so can you go a little bit up the point number one? I want to understand this partition. What is the difference between partition and point number one?
this is totally physical design, right? Entire thing is called as summarized in one word. Whatever gate level netlist we have, we are converting that to physical form.
But dividing chips into blocks means already in the top, like if you go point number one, where you can you scroll up the notepad, sir? There we have already, yeah, specification of IC. We already know the blocks, and then I'm trying to understand what is the difference between that one and then this one. The blocks in IC,
Already
we
you
all
have, see that is in the paper, right? What is the blocks you want in the IC? That is in the paper. You are not done in the tool, correct?
okay. So now we
That
have
is in
that.
the paper. Okay, this blocks you need in IC. So what is the estimated area from the previous project? The same type of IC we have implemented. This was this much area we have, but actual area comes from where? Actual area of IC. How we will get? It is nothing but sum of area of all these cells, right?
Yeah.
So you are doing this in tool now, right? It is sum of area of all these cells. So you add all this AND gate area, OR gate area, inverter area, this AND gate area, inverter area. Right? If you add all this area, so then you will come up with what is the IC, what is this chip requirement, right? Total requirement of chip, how much area. So what is that? For that reason, I have told this is a estimated area, right? I never told this is area of chip. This is estimated area. Okay, I can have this much area of chip. I mentioned I've used the word called as estimated. That is not the exact area.
So
Based on
my
previous
point.
project, you can estimate, okay, this may be the area. Around this, we may get the area. Right?
Okay,
Yes,
all
tell
are
me.
estimated area, estimated power. So I thought like the blocks already we defined it here. Like, what is the difference between this one and then partition of
No, no, that
part?
is just on the paper, right? You can, when before starting an house, they write it in a paper, correct? Okay,
Yeah.
this is how it should be there, right? It is just in a paper. Okay, this much block should be there in that. This must be the estimated area according to that previous project. This is estimated area. In this project, we have one module extra that may take some 10% of extra area. The previous project we had area of entire chip was, you assume it is just 100 centimeters, right? 100 centimeters square. Now we have some additional logic, so we'll take some 20% extra. Now this area may be, area of chip may be some like 120 centimeters square. So that they will estimate it, but actual area we will get only through the cell area, right?
Okay.
After what is a cell? that they have taken 10% extra area just as a estimation. But that is not the now we are not doing estimation. Now we are doing really in the tool we are calculating what is the area requirement of all the cells. Based on that we will calculate what is the chip area, and for each block what is the area requirement. For temp 1 how much area we want, that is reserved, right? That is for each block 1, block 2, block 3, block 4. They are reserving the area for each block. Now you got, that is just a
Yeah.
estimate, not the
So,
reality. This is doing in tool.
so
This you are not doing.
estimation, and then after synthesis, we get a gate level design. There might be a difference. You're saying that.
Estimation is obviously different, right? Estimation is on the previous project. Okay, previous project to this project we will not use the same chip. We will
No, no,
modify the chip.
estimate.
Logics we
No,
add. So I will not know how much area I will add extra, but I will assume that okay, that may lead to 20% extra. So after physical design, after estimating, after this step, right? When I do this partitioning, I may end up with the same estimation, whatever what was done at the beginning, or I may end up with little bit lesser area. I may end up with little bit more area. The estimation, see, you have marriage, right? Before marriage, you will estimate 500 people may come to the marriage. Based on that, you will reserve all the food, everything. But there is a chance that lesser people may come or more people may come. So what at the beginning we have estimated, that is the estimation. But in reality, it may change. It may become lesser or same, or it may increase. So that is just a estimation, the specification. But here in the reality, we are actually calculating area, layout area, and we are deciding what is the area of chip.
but
Now, after creating two different blocks, right? Now, directly we will not jump into top level physical design. We'll go with what? Block level physical design. So every block level engineer will parallelly start working with their block level physical design. So block level physical design, you have these many steps: floor plan, placement, CTS, routing, and sign objects. So what is floor plan? Floor plan starts with creating core area and die area or block area. The first step is creating core area and block area. Means whatever block you have, right? Whatever block area is given, according to that, you will take your separate block. For the separate block, for example, B1 block, this is your B1 block. For B1 block, first you create core area, and outside that, you will get one more area that is called as what? Block boundary, right? This is called as block boundary. And this is your core area. So how to create this? What are the factors affecting this core area and block boundary? Right? That is what we are going to discuss in your tool. So we cannot randomly create. So we should create based on our netlist how much each cell will take area, right? So based on how much each cell is going to take area, so I should create this area so that this core area, right? I should create this core area in such a way that it should accommodate all the cells present in the netlist, layout of all the cells, right? So like that, I have to create this core area. So how to create that? What are the commands for that in the tool? So how to create this block boundary? What is the distance between core area and block boundary? So on what factors this distance depends, right? That is covered in advanced part of physical design. And what are different methods to create this core area and block boundary? So after creating core area and block boundary, right?
that will be called as die also, right?
It is called as die only the full chip at the block level. So in the full chip, if we create like this to the full chip, right? So this inside is called as core area for full chip. This is called as a die area for full chip. But
Okay,
the
we don't
block
call it level. Okay.
we call it as block boundary. So next step in floor planning is port placement, right? So what was the port for your temp 1 block? So I am doing block level, right? I am doing block level physical design means I am doing physical design for this temp 1 block or temp 2 block. So the engineer responsible for temp 2 block, he will do physical design for his block. Temp 1 block physical design engineer, he will do physical design for his block. What are the ports for temp 1 block? M, M and O, and another port is P. Right? You have to place these ports. See, either you be in a silent area if you're unmuting, or please, if you cannot be there, please mute it. Right? You please unmute only when you have questions. Right? M, N, O, and P are the ports for temp 1. Right? These ports we have to place here, but we have to place physically. Ports means what? It is a metal layer, right? Physical form of port is metal layer. So place ports M and O and P. So here I have taken a small example. I have only 4 ports, but in reality you will be having hundreds of ports per block. Do the port placement.
The port
The
placement
ports are
means
simple metal layers.
input and output, right?
Yes, these are inputs. These are all outputs. So these are all input ports. These are all output ports. So ports, say whatever we have now in the netlist, everything we have to convert into what? Physical form. Here M and O means I have to convert the physical form. Physical form of ports are what? Piece of metal layers. These are piece of metal layers. So next after port placement, we have macro placement. So what are macros? So macros are complex cells, right? Macros are complex cells which are already designed. See, if you want to reuse in any, see if you feel any cell, right? Any complex cell which you want to, which is already designed, and if you want to directly use in your block, you can use it. See, this macros need not to be written. We need not to write the Verilog code for that. We need to do synthesis. Only we can directly reuse its layout if it's available. Right? Directly reuse the layout of the macros. So, for example, I need SRAM in my block, right? In my block, I need SRAM. Instead of writing the Verilog code for SRAM, instead of doing synthesis, directly I have layout for SRAM. So directly use the layout of SRAM, right? Why you want to write the RTL netlist and you want to do. So normally used macros are SRAM, because SRAM will see SRAM will always result in more cells. For example, if I am using, if my SRAM size is 1024 cross 8, what is the meaning of this? This SRAM has 1024 storing elements. 0, 1, 2, 3. It can store 1000. It is having 1024. I start from 1, right? 1, 2, 3. It's having 1024 storing elements, and in each storing element, you can store how many bits? 8 bits. This is the meaning of 1024 cross 8. Or if I have 1024 cross 32, what is the meaning of this? I have 1024 storing elements. When each storing element, I can store how many bits?
32.
32 bits. So now, this will result in each transistor, right? 32 bits will result in each transistor. I have 32 transistors into what? Here I have 32 transistors. Here I have what? 32. Here I have 32. Like
10.
30 continue till 124. So 32 cross 124. These many transistors I have. So I need not to write the Verilog program, and I need not to implement this SRAM by using basic gates. So there is already a SRAM compilers, memory compilers. From memory compilers directly we can create the layout of memories. and if the layout is available, directly you can use the layout here. So generally SRAM and PLL, right? Phase lock loop. So for PLL is analog circuit. What is PLL? It is a analog circuit. It is not a digital circuit. Digital circuits will work only with logic 0 and logic 1. Analog circuits will work with sinusoidal waves. The wave is very continuously changing. So PLL is a circuit, is an analog circuit. So we cannot design through by writing Verilog code. We cannot write Verilog code for analog circuits. We can write Verilog code only for digital circuits. We cannot implement these methods for PLL. So PLL is designed separately by using a full custom design team, analog team, and they will give layout of PLL. They will directly give what layout of PLL, and SRAM layout we will get from memory compilers. So directly we will use those layouts. So those are complex cells. These are not small cells like standard cells.
What
So
is
directly
SRAM?
So that is basic, right? It is a static RAM.
Static RAM, okay.
DRAM, dynamic RAM. SRAM is static RAM. So directly place this. So I am using 2 SRAMs in my design, or 3 SRAMs, right? How many SRAMs you are using? You can do the placement of those macros first. So generally standard cells are placed in the placement stage. We are placing layout of standard cells here. So I'll come to this stage later. In the placement stage, we'll place what layout of standard cells. Layout we are not trying it. Layout for the standard cells, right? AND gate, OR gate, NAND gate, NOR gate. We are not going to draw the layout. Layout is drawn by layout team. There is a separate team, full custom design team. They will give the file for us, layout file. We will use that file. We will directly place the layout of cells. We are not going to draw the layout. So here we are going to place layout of cells, right? Layout of this AND gate. So in the netlist, what I have, AND gate I have. So place the layout of AND gate, place the layout of OR gate, place the layout of what? Inverter inside core area. These are standard cells. So these standard cells will come into picture later. But now we are placing macros because they are the complex cells. Place them first. So in any block, if you see, the count of macros will be less. It will be from 5 to 100, right? Within 5 to 100. The count will be from 5 to 100. So for that reason, we will place this first.
So macros will be different sizes, or like it will be same complex size?
No,
Like,
it can be of any. It will be only in rectangle shape, but it can be of different size.
okay.
Size can be different. One macro even it can be little bit. Width can be bigger, right? Like this. Can be big.
Based on the complex logic, they can go bigger.
Yes. So first place the macros because macro count is less, right? But standard cell count will be in lakhs. But macro count will range from 5 to 100. In rare case, if your block is using more SRAM, it may go to 300. So not more than 300. But what is the count of standard cells in a block? It will be in lakhs. How many standard cells I have shown here? Only 3. Right? For simplicity, we have shown only 3. But like this, you will be having lakhs of cells in the netlist. So next is power planning. So we have seen the layout here, right? Layout. When I place my cells, I need VDD and VSS connection. Every cell needs what? VDD and VSS connection. For the chip, VDD and VSS connection will come from the outside world, right? Will come from the outside world. From outside world, it will come to the chip. From the chip, you will pass to what? Blocks. From the block, you will pass to what? Cells. So every cell require VDD and VSS connection. Every standard cell requires that because you can see the layout of cell. If you see, it requires VDD and VSS connection. So in my block, I will be having rows together cells. After placement, I will be having lakhs together cells in the block. Every cell requires VDD and VSS connection. Then efficiently plan the power how to give the power for all the cells, right? That is done in power planning, and we will discuss in physical design, right? How to do power planning, how to reduce the IR drop issues, right? So how to see if IR, what is IR drop? For example, I have one cell, right? You assume I have one cell here. I have one port here. So this is VDD port. From this port directly I am connecting to this cell VDD. Right? I am making a connection through metal layer. Now when this cell is switching, right, it will conduct the current. From this it will conduct the current. Current will flow through this. So metal has internal resistance. That is well known thing. Inside the metal we have what? Resistance. And current is flowing through this metal layer. That will lead to what? V is equal to I into R. Current is flowing and metal has what? Internal resistance. So if my VDD is 1.5 volts, out of 1.5 volts, only 1.2 volts will reach here to the cell. Remaining 0.3 volts, what happens? It will drop on the metal layer itself. And this 0.3 volts will convert to in form of what? Heat. Law of conservation of energy, right? So this voltage will convert to what? In form of heat. So I am giving 1.5 volts here as VDD, but what is reaching to my cell? 1.2 volt. So 0.3 volt is lost. So because of this less voltage reaching to the cell, that may lead to many issues, like switching problem it may lead, or it may lead to the problem like cell delay will increase. Right? So this is called as IR drop. Out of VDD, whatever I am giving, I am getting less VDD at the cell side because of this metal resistance. If I have more length, I have more resistance. If resistance increases, voltage drop also increases on top of metal layer. So to avoid this, how to plan power to avoid this IR drop? Right? How we can plan this power? So that we will see it in what? Power planning. Right? So what is power planning? Connecting all cells with VDD and VSS with less IR drop. IR drop happens on metal layer. After power planning, we have what? Placement. Placement means place
Uh,
all standard cells in core area. Yes, please tell me.
so we don't use decoupling capacitors in
That we will
macro.
discuss. Right? I cannot discuss everything in 3 hours.
Okay.
That I'll
No,
discuss when the course is when the course happens. So we use decoupling capacitance. If the voltage drops, right, even the voltage can be boosted by decoupling capacitance. Decap cells is used.
so without power supply, we can use that.
No, decoupling capacitance also should charge, right? What is the role of decoupling capacitance? So whenever the voltage goes down, it is like your home UPS, right? Decoupling capacitance role is here home UPS only. Whenever this voltage goes down, right, 1.2 volts, this decoupling capacitance will boost it. It will boost to what? 1.5 volts. When it is boosted down, this decoupling capacitance voltage will come down, right? Because this charge is gone. This decoupling capacitance voltage will come down to what? 1.2 volts. Again, it has to be charged. For charging, again, this VDD connection should be there, right? It's like your home UPS. So home UPS will supply the power when there is no power, but when there is power, it has to charge. So that VDD is required. Without VDD, we cannot even use it. Role of decoupling capacitance is if the voltage comes down, boost that voltage. If the voltage is coming down to 1.2, boost that back to what? 1.5. But when it is after boosting, the charge inside decoupling capacitance will fall. Again, it has to charge. Charging happens to VDD only. Again.
So first it will go to the decoupled capacitors, and then always first it will charge if you add
That
a
you can
decouple.
understand when we go through
Okay.
power planning, how this architecture is.
Okay. Okay.
See, that I cannot explain within this 3 hours of session. That we will understand only when you go to physical design, how it is in depth. Now, just I can give introduction like what we do in physical design. That's it. Just a basic idea I can give.
Okay, thank you.
So, what is placement? Right? In placement, we will place layout of standard cells. See, I repeat once again, right? We are not going to draw the layout. Layout is drawn by layout team. So, we'll take those layout and here we'll place layout of standard cells inside core area. So, we have latched together cells. So, these cells layouts are placed inside the core area. So, this is layout. This is about placement. Right? After placement, we will do CTS. CTS means what? Clock tree synthesis. So clock tree synthesis means build a clock tree using inverters and buffers. So now we have to build a clock tree like this, right? In CTS. We will build a clock tree like this. So now earlier one clock port will be connecting to all the flip-flops. Right? One clock port is connecting to what? All the flip-flops. Now it's connecting to all the flip-flops. So one clock port which is connecting to all the flip-flops, it will increase the load on the clock port. This will increase the load on the clock port. This capacitance load will increase on the clock port. And now whatever the clock we are getting, this is a normal clock, what we see, right? But now the clock will take more time to charge and more time to discharge. So we will lose the shape of the clock. Instead of square waveform, we'll start getting what? Triangular waveform. Why? Because on the clock port, we have huge load. How this load capacitance is formed? So every cell has pin capacitance, right? This pin capacitance plus this net capacitance. So this metal layer has capacitance with respect to ground. So this net capacitance plus this every cell's pin capacitance is going to form what? A load capacitance. This capacitance we are not connecting it. It is by default formed. If this capacitance is completely charged, that is called as logic high. If the capacitance is completely discharged, it's called as what? Logic low. So when I have a clock, 1 gigahertz clock, so one entire time from here to here is how much? 1 nanosecond, right? 1 gigahertz means is 1 nanosecond. So now if I have huge load here, it will take more time to charge and more time to what? Discharge. So square waveform of clock is converted to what waveform? A triangular like waveform. So this is not acceptable. So we have to reduce load on the clock port. To reduce load on the clock port, what we do? We will go with clock tree synthesis. We will build a clock tree like this. Right? First, this clock port is connecting to only one buffer. And now this buffer is connecting to only these two buffers. And again, this buffer is connecting to other buffers like this. And this buffer is connecting to flip-flops. So now start building the tree-like structure. Right? Now one clock port is connecting to only one buffer. And this is connecting to what? Two buffers here. And this buffer is connecting to other two buffers here. Output of this buffer. And this buffer you connect to what? Flip-flops. This will connect to flip-flops. So now the load on the clock port is reduced. Now the clock port is only driving what cell? One cell. This cell is driving only this cell. Now wherever I see, I will see clock like this. I will not see triangular waveform. So to avoid this, we will build a clock tree. So how to build a clock tree, right? All these things, how to build a clock tree, how to insert buffers. So all those things we will discuss in clock tree synthesis. So what is necessary, actual necessary of building clock tree? There are many parameters, clock transition, clock capacitance. So we'll understand in CTS. So after building clock tree, Next we'll go with routing. Routing is nothing but connect all cells, connect cells, macros,
So
and ports with metal layers. That is called as routing. So here we can see what is the connection made here, right? Here output of AND gate is connecting to what? Input of OR gate. So output of OR gate, where is the output pin inside the layout? You check. Where is the output pin inside the OR gate? You check. And where is the AND gate? Input pin of AND gate, you check and make the connections like this. Make the connections by using metal layers like this. Connect the cells.
So metal layers will be same, or there will be different metal layers for each connection?
No, I didn't understand what is your question.
So I mean to say the metal layers, I read somewhere like metal layers will be have a different M1,
So you
M2.
will be having metal layers from M1 to M9. Right? Stack of metal layers you can use. For example, now I want to connect from this cell to this cell. This cell output pin should connect to what? This cell input pin. So now if I am connecting like this, what happens? I will short here, right? Means I will make unnecessary connection here, correct? I cannot
Yes,
route
that
now.
is
Now what I will do? This metal layer, first what I am making connection is by using M1. What is this metal layer called as? M1. This metal layer is M1. I will be having one more metal layer that is called as what? M2. M2 means that is different metal layer, right? I'll take M2 here. I am crossing here. This is M2. So M2 is on top of M1 is M2 is on top of M1. They are not present in the same plane. M1 is present in the ground plane. M2 is present on top of that like this. So now there is no short. Means there is no connection formed here. Now you can route. So like this, you will be having different stack of metal layers. The stack of metal layers will range from foundry, right? So in our design, we have stack of metal layers from M1 to M9. Means on top of M1 we have what? M2. On top of M2 we have M3. On top of M3 we have what? M4. Like that, we have stack of metal layers from M1 to M9. Why this stack of metal layers are used? Because we cannot make connections without making shorts, right? If you want to make connections without making shorts, then we have to use upper metal layers. So if this pink color is M1, then yellow color is what? M2. This yellow color is on top of what? M1. Here there is no connection made.
So if I want one more connection, then I can do only M3 now. So
Yes. If I want to route here to here, right? From here to here I want to route, then I should use some other metal layer like M3, right? Use M3. This is M3. This M3 is on top of M1 and M2. It is not making any connection. So
so
M3 is
that
on top of M2. They not make
that
any short with M2 or M1. So like that you have stack of metal layers.
so that is the sequence will go only based on how many it is going through from one layer to other layer. So like if I completed M1, then I can only use M2. If I completed M2
No,
over
it's
there.
not like that. No, your tool will do based on the timing, right? Higher metal
Oh,
layers will be having less delay. Lower metal layers will be having more delay. So whichever routing is coming in the critical path, it will use higher metal layers. So what is critical path? You will understand only when we understand what is STA, static timing analysis. For example, this routing is coming under the time critical path. Means I am seeing this cell is coming under time critical path, means this in this path I am seeing timing violation. Now route with higher metal layer because higher metal layer has less resistance and they have less delay, right? So based on that, my tool will decide which metal layer I have to use out of M1 to M9. So all those things understanding cannot be done in one day. So you can understand only when we go through the course.
so that
So
is
how my tool
handled.
selects.
Only tool will handle these layers, so we don't need to worry about it.
We will not route it because we cannot route for the lakhs of cells, right? We cannot manually route. All those things, even placement tool will do, even routing tool will do. we have to check if there is any violation, then we have to correct it. That is the role of physical designing engineer. See, there are many checks comes in between, right? After route placement, it's not that okay, placement is done. Right? We have many checks after placement, many checks after CTS, many checks after routing. If everything is good, then only we'll proceed for the next stage, next step. So all those checks and validating if everything is correct, that is role of physical design engineer. But all these steps is done by tool only. Tool only will do all these things.
So once placement is done, then there is a after placement there is a check of all the placement things. Then only once it is done, then we'll go to the
Yes. What are the
CTS.
checks we have? Right? We have a PPT, right? What is covered, right? We have all these checks. So checks after placement, right? I mentioned we have congestion, max cap, max trans, max fan out, setup violation. So all these things, if we ensure, see, I cannot explain this in one day, right? Because this placement itself will take 2 weeks to complete. So all
Yeah.
these checks are completed, then only we go for next step. So this is our course content, right? So just first I'll complete this. So connect all the cells by using metal layers. Next we'll do sign off checks. So we have 3 sign off checks. One is timing sign off. Timing sign off means validate the STA, right? Validate static timing analysis. Yes, please listen. You can discuss later. Validate STA. So STA mainly has setup. See, we have many things in STA. We have setup and hold violations. Mainly it is focused on setup and hold violations, but we have many issues like max trans, max cap violation, max fan out, crosstalk. Right? So all those things you validate by using a separate tool called as, see here physical design is done by using a tool called as ICC2 or prime time. I'm mentioning only synopsis tools. So timing sign off is done by using separate tool called as star RC or prime time. Right? Separate tool it is. So verifying STA, there is no timing violations in my tool. We have to verify. So what is setup violation? What is hold violation? How to verify STA? Right? You will see that. So next is we have IR drop and electron migration. Electron migration. So this is done by using a separate tool called as Red Hawk. So in this we will check whether there is less IR drop. So which net is having more IR drop and why it is having more IR drop. So all those checks we will do in IR drop verification and electron migration. Electron migration means whatever metal layer we are seeing here, right? This can conduct only certain amount of current. If we exceed the current passing through this, then this metal layer will melt away. Then my IC will not work. That is called as electron migration. That is what the concept used in fuse in a home. Right? If you have fuse in a home, if you open the fuse and if you check right MCB inside the home, the electrical house board, so you will be having thin metal layer like this thin metal layer, thin metal piece will be there. If high current flows, then the requirement this metal layer, this metal will melt away. If metal is melting away, the connection is cut from outside the home to the inside the home. Right, the connection is cut so that high current will not damage your appliances. So similar way, if you pass high current, your metal will break away. That is called as electron migration. So those checks you will see, right? You will check which metal layer here is conducting more current, more than its limit. You will check all those checks is done by using a tool called as Redop. Next, you have physical verification. So physical verification means generally you will do DRC, design rule check. See, Foundry would have given some rules. So you have to check whether you are maintaining that rules or not in your physical design, right? So your foundry would have told from one metal to another metal, you have to maintain some minimum spacing, whether you are maintained minimum spacing or not. Here. minimum spacing you have maintained or not. So there are many rules from foundries. Whether that rules are maintained or not, you have to verify. If it is not maintained, you have to change the design. If you meet foundry rules, then only your IC can be fabricated. So next you have LVS, layout versus schematic. This is layout. What is schematic? Here netlist is your schematic. What is the connections mentioned in the netlist? The same connections is happened in the layout or not. Here in the netlist, output of AND gate is connecting to what? Input of OR gate. The same connection is happening here or not. You will check. If it is happening, then your LVS is clean. If there's some unnecessary connections are seen or connection is not happened, right, then your LVS will fail. You should do this LVS. So main thing is DRC LVS in physical verification, and we also have electrical rule checks, ERCs. So we have many rules. So whether subset is connected to VDD or not, NVL is connected to VSS or not, any input is floating. Right? We have many electrical rule checks. If that is met or not. If it is met, no issues. If it is not met, then we have to fix it. So if this all sign off checks have done, if it's validated, then your block level physical design is done. After doing block level physical design, you will send this block to what? Full chip. Full chip person will integrate all the blocks. He will create the GDS for this entire chip, and he will send this GDS to what? Foundries. So this is the flow what we have in physical design. So what we cover in our physical design means we will cover all these things. So we will do two projects, one with 28 nm, one with what? 14 nm. So this is the specification of the projects. The count of the cells will be 52,000 for one project. Another project will be 1 lakh. See, we cannot run on 5 lakhs or 10 lakhs, because if you run on the block with 5 lakhs or 10 lakhs, right, the runtime is very huge. Means to execute one command, we have to wait 2 days. If I use 5 lakhs block, right, to execute one command, that command execution will take 2 days. In industry, we can wait, but in the while doing this training and all, we cannot wait. So all the institutes will run with a lesser cell count. This is a cell count, and this has a macros of 40 macros, that is SRAM, and these many clocks we have. In the design, we will not be having only one clocks. We have 5 clocks totally. Node is 28 nm and 14 nm. I've already mentioned, right? Sir, industry is working with 5 nm. Then why you are using 14 nm? See, industry has MOU with TSMC because the company will get fabricated their IC done there only. That is a MOU with crores of monies, right? Then only they will give their files to them. Physical design cannot be done blindly, right? We require input files for physical design. That should be given from foundry. For 5 nm, I require files from foundry, right? Then I should get files from TSMC. I will get files from TSMC only if I pay in crores. Only if I get my IC fabricated there. I cannot get that. So we will get only files which is given from Synopsys. Synopsys, they have their own foundry, small foundry, right, for testing ICs. Whatever the files given from Synopsys tools or from Cadence tools, those files we use. So Synopsys has given files only till 14 nm, so we'll use only till 14 nm. So we cannot run with 5 nm or 3 nm. That requires close together monies. Right? So these specifications of two projects. What we do?
But the tool will support, right? Synopsys, if real time they use, even TSMC give 5
Same
nm.
tool.
But tool will support even
Tool
5
remains
also.
same. Tool will never change. Tool supports. Whatever the version used in 5 nm, the same version we use, but input files, right? We require these input files. I mentioned here, these many input files we require. So physical description of standard cells. We require parasitic file, right? We require NDM files. We require left file, lib file, technology file from the foundries. If we get it, then only we can proceed. So for that reason, we cannot go with 5 nm or 3 nm. So we can only dependent on what is given by synopsis. Synopsis has given only till 14 nm, then we can use only 14 nm.
Okay, I understand. So the one they give like Liberty, all this HDC, that only supports for 14 mm.
Yes. See, we cannot do for 7 nm, right? I don't know why. What is industry person who has given? I don't know. So I am making, see, the demo, we are making it clear, right?
No, no, I'm just trying to understand like
No, I'm not
they're
asking,
like
I'm answering. I have some person with name Uday Giri has question. Right? See, 7 nm, 14 nm. What is the difference? There is no difference. Physical design, right? Only cell size is less. The standard cell size is less. The size of standard cell, right? For 14 nm, if you take, this will be the layout of 14 nm. What will be the layout of 7 nm? The cell size will be less. That is the difference. Anyhow, you are not going to draw the layout, right? Then both the flow remains same. You take 14 nm, 5 nm, 7 nm. This flow remains same. This flow will never change, right? Only few rules. I told this DRC rules. I told, right? These rules will change. All of it almost same. But for that reason, I will not tell that we are working on 7 nm. We can tell that only we are working on 14 nm. But there is no
Sir,
difference in
from
14 nm
14,
and it's almost same. But 3 nm, there will be slight variation with the rules. 3 nm of failing, there is a slight variation that we will discuss in the theory of the slight variation. Yes, tell me, what is your doubt?
from 14 to 7 or we are coming from 14 to 7. I think the speed will increase, na, sir. So it is a huge impact for the IC designs.
Speed is not dependent on the technology, right? You can run 1 gigahertz even on 28. Who is going to stop you?
Basically, in IC design, we are focusing on PAP, na, sir, performance, area, and power. So as performance increases from in a, in any aspects, such like speed, so it is a huge difference. It's matter a lot from 14 to 7 if we are going.
No, speed depends upon clock frequency, right? What clock frequency you are giving. That is nowhere. Speed is, see, speed depends upon the voltage, right? Speed depends upon the voltage of cell. So if I am running with high clock frequency, the cell should give less delay. If the cell should give less delay, then my cell should operate with higher voltage. So with the technology involved, what voltage we can operate, based on that the speed depends. In the higher perspective, you cannot understand this, but when you understand STA, right, you can understand how the speed and voltage dependent. For example, for 14 nm, what is the voltage I can use, right? What is a VDD I can use for cell, right? Based on that, the cell delay will depend. Based on that, the speed of operation will depend. So I think I don't know what you're speaking about. It's not about if technology reduces, you cannot operate with higher speed, or if higher technology can operate, we can operate. But it depends upon the voltage. What is the cell voltage? So whether my question is, I am working with 1 gigahertz for 14 nm. Whether I cannot work with 7 nm with 1 gigahertz, or 1 gigahertz I'm using 7 nm. Whether I cannot run 14 nm with 1 gigahertz, I can run. So I have to run with 1 gigahertz means my cell should give less delay, right? I have to check whether 14 nm is going to support the cells which are running with 1 gigahertz. Means cell should operate very fast. If the cell should operate very fast means cell should take more VDD. What is the VDD limit for the technology, right? We should check that. So that is all the constraint dependent, right? But flow remains same. Flow is almost same. Whether this flow will change, flow will not change, right? So while fixing timing, there will be some troublesome, right? Trouble will be seen while fixing timing. Trouble will be seen while fixing DRC. So that will change not only with technology, that will change from project to project. In same 28 nm, if one person is handling 50,000 cells, if other person is having 5 lakh cells, obviously we will see difference in fixing the issues, right? 5 lakh cell person will see more issues, and 50,000 person will see less issues with the same technology, right? So issues in physical design is not only dependent on technology, it also depends on complexity. What is the complexity used? So according to me, 7 nm and 14 nm doesn't have any drastical changes. It is having almost same issues, but 14 to 5 or 3 you have more changes. You have drastical changes from 5 nm to 14 nm. So double patterning will come into picture with 3 nm, 5 nm. Double patterning routing will come, and you have some diffusion rules, diffusion placement rules, implant layer rules you have. So those rules will come under 5 nm or 3 nm, right? So that is not seen in 7 or generally with 14. Some additional rules will come into picture, but 14 and 7 almost both are same. So next is, right, we will discuss on. So here we will discuss on what are the input files required for physical design, and what is static timing analysis, what is setup and hold, what is different types of clock, what is latency skew, multi-cycle path, false path, asynchronous paths, D rate, QT conditions, right? All those things we'll discuss in STA. So next we will discuss about synthesis. Synthesis will do both logical synthesis and physical aware synthesis. Right? So we'll do all these things in synthesis. So if we are doing physical aware synthesis, inside physical aware synthesis only we will do floor planning also. Right? So all these things are floor planning. Planning core area, die area, macro placement, port placement, physical only cell, power planning, right? Power aware logical optimization. So all these things we'll do. So physical aware synthesis means do synthesis after floor planning. Logical synthesis means do synthesis before floor planning. So both will do. So next is placement, right? We will cover all these things in placement, types of placement, different types of placement of cells, what are placement optimization techniques, what do you mean by blockages, bounds, and magnet placement is going to control the placement. Next, what are checks after placement. So next we'll, this is a chip, this is an example of the physical design we done for one block, right? And this is a congestion after placement. So we'll check the placement checks like this. So these regions are hotspot, right? I am seeing more congestion here. Congestion means shortage of tracks for routing. So all those things you understand. So here I have more violations. So all those issues we have to fix. This is a map where I am seeing more red color, right? We have more issues. So we have to fix those issues. So we'll check the congestion like this. Next we'll check next we'll see what is clock tree. So in clock tree we'll see what is clock tree specification file, NDRs, clock buffers, clock transition, latency, CTS exceptions like float pin, exclude pin, what is clock balancing points, non-stop pin, types of clock trees, MS, CTS, H tree, right? CTS steps, what are steps in CTS, and what are checks after CTS. So these are checks after CTS. Then routing, right? What is different types of routing? What is crosstalk, electron migration, antenna effect? Steps in routing. What are routing optimization techniques? How to improve the routing? How to do buffer on routes? What is DRC check and LVS check? We'll do. This is a clock tree example which is done in our tool. So this is an example of shots, right? Wherever I'm seeing shots. So same metal layer. This metal layer is M6 horizontally, vertically also M6, right? Both are connecting here. This is a shot. So in this region, there is a shot. Red color is shown here, right? In the red color region, I have shot. If I zoom this region, it will be like this. So we have to fix these shots. So how to fix these shots? So we'll discuss all these things. So next is sign off checks. We'll do timing sign off, physical verification, IR drop and electron migration. So this till now we will do hands-on. Only this will not do hands-on, right? IR drop and electron migration is not done hands-on because we don't have radar. This only this step is done theory. We are not doing hands-on for this. Apart from till this point, we are doing what? Hands-on. Starting from synthesis till physical verification. But only IR drop and electron migration it is done theory. Internal to the physical design, we will do advanced physical design. Writing optimization scripts for all these things we have already written. Like this, we will write some optimization. This is a tickle program, right? For port placement. We have written some tickle program. And this is a tickle program to find this voltage area. To calculate voltage area, we have written some tickle program, TCL program. This is a TCL program. So we have written the tickle program to create the macro rings. Around the macros, we'll create VDD and VSS ring. So we have a tickle program for that. We are creating VDD ring. This is a VDD ring. This VSS ring around the macro we have created. So this is a tickle program for that. This is congestion fixing methods by using tickle. This is to find number of flip-flops which not having clock gating cells. We have tickle program for that. And useful skew. Right? How to fix the timing issues by using useful skew. So we have tickle program, automated tickle program for that, TCL program. So all this we will cover enough tickle program even in advanced part of physical design. I told you tickle is very important, right? While using tool, we write many automation programs like this to fix the issues. So all these are examples of that. So this is what we cover in our physical design. This is our course content. So I will stop here, and if you have any doubts for next 2 minutes, you can ask.
So do we use any automation for these steps physical design by using any coding techniques?
Yes, we have told the tickle programs for that reason only, right?
What is
This is
the
to
like
fix automation
Python?
fixing. No,
Is that
tickle
the
is a
Python?
PC.
Oh, this is used in like industry or like it's just for like institute?
See, industry, as a PD engineer, you will not write any program, right? It's already inbuilt. Every, I can tell the flow is already built. Just have to run the flow. If any particular, for example, you will get 1,000 violations. How to fix 1,000 violations? So you cannot fix one by one. How to write a tickle program to fix 1,000 violations? So like that, we have written many programs. In fact, we'll tell in industry will not write any programs. So that is already done. Industry has well-defined flows. Right? They've already done. But we are teaching you how to write the programs if you get issues. So we'll write the program only if we get issues in that particular. So why will it simply programs, right? So we are not here to teach like ABCD, right? We have to teach the industrial standard. Then only you can survive in industry.
Yeah.
Why will it? We will not write like that.
Sir, how to get recorded video, sir?
This recorded video, what we have done. See, session
Yes,
recorded
actually,
video.
we recorded this video. So how do I get?
When you register for the course, they will give you username and password for the one
Yes,
portal called as InSkill. And if you log into that, you will get all the recorded videos of the course. But this recorded
Sir,
video
how
you can
many?
ask in the WhatsApp. For this demo recorded
Sir,
video,
how
you
many
can
days this
ask
course
in the
will go,
WhatsApp.
sir?
So please allow me to talk. This recorded video you can ask in the WhatsApp. So they will give you the YouTube link. So you can see this demo recorded video. This course I already mentioned at the beginning. It is for 6 months. Split up is here.
Okay, sir.
Basic is for 2 months and advanced is for 4 months.
Sir, we need to pay any money, sir, for this course?
What is the question?
Sir, we need to pay any money for this course, sir? I'm asking that.
6 months course, yes. This is a course which is driven through the fees, right?
Okay, sir. Like basically,
Fee
how
structure
much, sir, it will?
Yes, please tell me.
Hello. Like how
Yes, please
basically
tell
how
me.
much sir it will be? Sir, I'm just asking how much it will be the mean cost.
63,000 almost around.
Okay, sir. Thank you, sir.
Okay.
Sir, for online students, are you providing material or PDF, sir?
No, you can repeat once again.
For online students, are you you are providing materials or any PDFs? Little.
So there is no difference between online and offline, right? You are also attending the session there from your home. You are attending the live session itself. But all the materials are given. Whatever materials, what are the sessions after session, what are the materials they have used, it will be given to every student. But what are the
Like it's a
materials,
book,
what are the materials they have inbuilt, everything will be given to the students. It will be given,
like
it
it's a
will be
book
forwarded to
format or
the.
PPT, sir.
Yes, please
Like
repeat
it should be
again.
built in PPT, sir.
See, whatever they use in the class hours while explaining, that will be given. Even the commands, everything will be given. Commands which are used in the tool, it is not given to the students. You can use from the server. Server we have, right? We will give the location. You can log into that and you can use from the server. And whatever theory session is done, PPTs also we have inbuilt PPTs like, and whatever we have written, right? Even that is also forwarded.
Sir.
Sir, what is the starting date of this course, sir?
This is starting date, right? That's what you're
Yeah,
asking.
yes, sir.
Uh,
Sir, I am Devendra Rao. So,
it will be from tomorrow itself.
okay, sir.
Basics will start from tomorrow. So tomorrow we'll start with JVM. That is what our normal practice because JVM you
Yes,
can
sir,
learn
I
in
am
any time.
joining in April month, sir. So, you can tell me April month is starting date, sir?
See, you can see the website. See, we
Okay,
will
sir.
start for every month. I'm not sure about the date when we start on April month.
Okay, okay, okay. Okay, sir.
Uh,
Thank you.
and sir, you will continue all
Sir,
these
what is the
6 months, or
timings of the class, sir?
someone will do for 2 months, and then after like PD advance, some other will come in.
Yes, yes. Trainers will change in between, right? Person who is
Okay.
doing basics will not do the PD advance. So the
Okay.
trainer is there different for the lab and trainer is different at the weekend.
Okay. So those details will be shared in our like common chart.
Every information will given you. What at what time session happens, everything will be told to you for that week. For
Okay.
example, from Monday your session starts, right? Friday they will inform next week schedule. What is the thing?
Okay.
Sir, I have one question, sir. Hello.
Yes, tell me.
Sir, like you said, we have to give the mock interview, then we will be added into the placement group, sir. So it has some validity, or once we have cleared the mock interview, then we
Okay, I
can
think
give any number
answered.
of interviews, sir.
I already answered earlier, but I'll repeat it.
Yeah.
You can take
Yes, sir.
mock interview n number of times. There is individual official WhatsApp group. Whenever you
No,
are
no, sir.
prepared, you
I
can
am
take it.
asking once I have cleared the mock interview, then we don't have to give it again. No, sir.
No, you may
We
not to clear. You can just wait till you get placed. That's it.
okay, okay, sir. Okay, thank you.
Mock interview is done by industrial officials from industrials who are their trainers, mentors. They will do mock interview, but you
Okay,
will
sir.
be having interview from the company side, right? When you
Yeah,
attend the
yeah, yeah,
company,
that is okay, sir. Yeah.
that is there. So we will not do mock interview again for the candidates who are already clear.
Okay, thank you, sir.
See, once when we send any candidates to the company, for example, I send 10 candidates, and we'll get a feedback from a company to us back from VLSI Guru out of 10 candidates who are performed very good and who are selected and who are very weak. So we get a feedback from them. Right? If we get feedback, they are very weak, we will support them. We will not conduct mock interview again. We will support them. So you, even though you are very good in the skills, technical skills, but you have some communication issues. Right? Please improve that. You please talk to our. We have some communication trainer to talk to them. Right? We'll support them. So as per
Okay,
the
sir.
feedback, we will support them. We'll tell, okay, this aspect they are telling you need to improve. Right? Please support. You need any support, you please ask the institute. So we will just give the feedback.
Okay, sir.
So currently, we got a feedback like little bit they have to improve. Then what we are doing, we are conducting some interview preparation session for them. How to answer an interview. For everyone will not get a bad feedback. For those who get bad feedback from the company, we will do some supporting session. Currently, for every this complete 1 month, for the students who are already undergone course with us for last 2 to 3 batches, we are doing only interview preparation session. Means only type question and tell answers for them, right? Like this.
Got it, sir. Got it.
So what is auto ungrouping? What is logical synthesis and physical aware synthesis, right? Like this. So what is physical aware synthesis? So only ask questions and type the answer. So we'll do supporting sessions based on the feedback. Okay, thank you everyone. Right?
So,
I'll end
so,
the
so,
Sir,
if you have any
sir,
queries,
I
right?
have some
Please
questions.
in the group. Yes, please ask me.
No, sir, sir, as in your website, it said that you have Red Hawk for IR drop and EM. So, as you said, you
I have
don't have Red Hawk.
demo. I made it clear. Right? We are not. We have reduct theory. Theory we will do, but we don't have tool.
So, in your official website, it's saying us, sir, we have that one.
We had a
So,
tool.
it's doesn't mean.
We had a tool earlier, but currently we don't have.
So, in
See,
order
reduct course,
to uh,
we have reduct course. In the reduct course, the tool is explained how to use the tool, but currently to do the hands-on, we don't have tool.
so basically, it's your problem, no, sir. So we are paying our fees, so it's up to you. So you have to manage that thing, na, sir.
No, I am not telling this after the end of your session, right? I'm telling on the demo class.
No, I just want to clear that one thing, sir. As I saw you on your website that
So
thing.
I'm telling in the
That's
demo
why I'm
class, right?
asking.
All is on you now.
So within a 6 months, you could not afford or you could not arrange that software for us, sir.
No, that skill is not asked, right? As a physical design engineer, they'll not ask mandatory you should be knowing IR drop.
Okay.
Question. IR drop engineers are separate
Okay.
again. Right? That is the physical verification steps, whatever we have timing, you can go if you are physical verification and IR drop. Those engineers are separate again. They will not do the role of physical design engineers. But that is added
Okay.
things we have given. But that theory part we will do, but we will not do the lab part. So
Okay, sir. Sir, I have two more questions, sir. Well, one is, sir, after completion of physical basics, then only we are getting 24 into 7 labs access, na, sir.
yes,
So
what
basically,
you will
it's
do
for
without
4 months.
what you will do without knowing the concept, what you will do with the tool. Okay, we can install you tomorrow itself, right? When you're undergoing basics.
Okay,
But what you will do without knowing what is the concept, right? So
that's
you will
not an
be
issue, sir.
okay after during the advanced class.
Just please listen to
No,
me, sir.
I understood.
After,
No, you can see there are few candidates who tell that okay, I know how to use the tool. You please give me the tool access. For them, we will give.
no, I'm asking in that, but I'm not asking that perspective, sir. I'm asking for after enrolling, after starting from physical advance, we got 4 months to practice for these sessions. After you said that you have 15 days after completion of the course to get an access for tools, na, sir.
Hmm.
If someone wants to practice after that, what he can do, sir?
See, you can discuss with the admin with genuine reasons. What is the role, right? You can, it will be extended. See, why we will not extend, why we cannot give students many time, right? Because students are misusing the tools. Means they will sell the tools to others, right? Tool is very costly. You will not get fusion compiler license outside. It is not a freely available tool. So the one license, right? It's very costly. So we are paying in lakhs to get the tools, and they are selling the tools right outside. So if you're for that reason, we will restrict the tool only for 15 days. And if you have any genuine reasons for continuing, and you can continue, you can discuss with admin and you can
Okay, sir.
continue with.
And
See,
a fresher,
and I
how
want to make
can?
one thing clear. One thing I want to make very clear. See, tool access is restricted only through VPN after 15 days. Means after course completion plus
Okay,
15 days. Right? Tool access is limited only through VPN, means from your home. But through institute, if you want to
okay,
work, if you want to use a tool in the institute by connecting to our institute network, right? You have a LAN cable, simple LAN cable. You can connect to our institute network, and if you want to use from the institute, you can use for 1 year, next 1 year. We don't have any see,
okay,
we
sir.
don't have any objection in if student tells, okay, I want to use for my practice. We don't have any problem, because that is why, that is how the student get expertise. That is how we also feel happy. But if we simply give, then they are giving the tool to some other persons. That is what it
Yes,
is
sir.
concerned with us. If you want to use from the institute, you can use for till you get the job.
Okay, sir.
It's not
Sir,
your
one
1 year.
last question. Yes, sir. Sir, a fresher, how much he can expect for a salary, sir? And what about the placement, sir, in your institute last year or last month?
See, on monthly basis, we cannot tell. As a placement, you please contact to the admin, because I'm a technical person. Office staff, you please
Overall
contact.
CTC, sir. Overall CTC.
CTC I can tell. Right? CTC I can explain, because I know what is a CTC, but what is a count I cannot tell. Last month count. If you want monthly count, how much they have placed, then please contact the office staff. They will inform you. Right.
Okay.
So what is a CTC? Right.
So,
See, there are two things. Right. When you're on the project without project as a fresher, it's not for the experienced candidate. As a fresher, when you join to any company, before joining to the project, I told you project means they'll ask you to work in if you are going to service based company, if you join to service based company, so immediately you are not working on the project, you will work
yes, sir.
with product based company, right? So till this phase, they will pay 15 to 20,000.
Okay.
So once you get the project of product based company, once you are onboarded for the project, so they may pay you as per their company guidelines. It will be almost 6 lakhs or 8 lakhs per annum, 6 to 8 lakhs. So that
Okay, sir.
joining to the company until getting the project, it may vary from 0 to 3 months. It's up to your skill, how fast you can clear the client interviews. See, once you join to service based company, to get the project from product based company, you have to attend the interviews of product based company. Then only they will allot you the projects. So how fast you will clear the interview is dependent on. So that may take 0 to 3 months. For example, if you join to one
Sir,
company and that company is bringing the ODC project, you assume, right, within 1 month. So then from the first day you will get the good package.
okay, sir, as you talked earlier, sir, if someone English professions is not better, so in your institute they are providing some English classes, so we have to pay for that one also.
No, that is not a part of this. That is part of this whatever fees they have allocated. There is no separate fees for it. Only
Okay,
thing
sir.
is you have to attend it properly. That is what the expectation is. See, English communication, I see through my experience, I'll tell one thing, right? English communication will never improve only by one day, attending only few classes, right? Day to day communication will improve your English. So that is, I'm not insulting anyone, or I am not thinking anything. That is a genuine thing what you can do, right? Talk daily, even though you are pronouncing wrong, your grammar has some mistake, no issues, but talk daily, right? So try to improve your grammar by seeing through some. See, nowadays we have many AI tools which can support you in improving your grammar, right? So you can undergo like this, and day to day conversation will help you in improving in your English, right? Make a conversation with a person who is very good in English, right? Try to communicate with him in English, so that will help you your English communication skills. But how to build up that? So we have obviously a mentor that is uh, that is free of cost. That is already included in the fees. We are not charging any separate for
Okay,
that.
sir. Suppose,
Okay,
sir,
thank you
suppose I
everyone.
want to. Okay, sir,
Yes,
sir,
please,
sir,
any
one
queries,
last
right?
question,
You
please.
can ask me. We have other sessions. Right? I have other sessions. If you have any other
Okay.
queries, please
No,
ask in
I will
WhatsApp.
just take 2 minutes of yours, sir, please.
Yes, please tell me.
Sir, as I want to enroll for weekdays, sir, from I think I didn't understand what you are saying at that time. From Monday to Thursday, 9 to 1 o'clock, there is a theory session, and Friday
That
is
is for
off,
advanced.
and
That is for
Saturday
advanced
and
session.
Sunday for lab sessions.
Advanced happens after the 2 months of basics. Now you can enroll for basics,
Okay,
right?
sir.
If you're enrolling for basics, you have only basics done. First, the basic starts with right? First, the basic starts with distal, GVM, Unix. So 2.5 months you will undergo basics. Then you will come for advance. So when you come for advance,
Okay, sir.
weekdays you will do lab. Weekend you will attend theory. Even you have to attend.
Okay,
So Monday to
okay, sir.
Thursday you attend lab. Saturday and Sunday you will attend theory.
Theory.
Sir,
It will
Sir,
be generally morning.
in initial months from tomorrow onwards, classes will be 9 to 1, sir. From Monday to Saturday or Friday.
Yes, it will be from 10 to 1 or 9:30 to 12:30, 3 hours per day.
From Monday to Saturday or Friday, sir.
No, this will be from PD basics will happen from Monday to Saturday. Sunday will be the off for this for PD
Okay,
basics.
sir.
It will happen from Monday to Saturday. Sunday will be off for PD basics for those who are enrolling for weekdays. For weekends, it will be only on Saturday and Sunday. That is separate. So you will be having from Monday to Saturday every day 3 hours.
Sir.
sir,
Okay, sir. Thank you.
sir, after completion of PD basics only, later next month we will have lab session, sir.
Yes. First, all the basics will complete. Right? Then only you can attend.
Okay.
Then only you can understand what is tickle. Right? Or else
At
without understanding
starting
tickle.
2 months, there is no lab session for weekends and weekdays batches, right, sir?
Yes. Advanced lab is not there, right? But all these are labs only. GVM, it is not just a theory, right? It is a
Okay.
one-to-one basis. Right? You should also do parallelly along with the mentor. Unix, you should do along parallel along with mentor, right? Tickle, you should do parallel along with mentor. So these three are labs only, right? In PD. This is
Okay.
not theory. You should bring your laptop or you should attend with your laptops.
Okay, sir. Thank you.
Sir, after completion the course, suppose if someone didn't get any placement or a job, so what is your help for these persons?
No, if you first you should clear the mock interview. If you're not clearing mock interview, we cannot help you.
Oh,
So we can only support you. Why you cannot cover mock interview? If you want any support sessions, right? We can give you separate support sessions. We can give you this one, right? We can give you the interview preparation sessions. As I told you, right? We are conducting interview preparation sessions now. We can do that. If you are not clearing your
okay, sir.
mock interview, if you are clearing in mock interview, I am 100% sure we we will not select the candidates who we are very weak, right? So after
Sir,
clearing mock interview, you are not able to if you're not getting the job means the situation will be either it is a recession session, it is a recession time, or some other reason. We'll identify what is the reason, right? Based on that, we can take a call.
okay. Sir, every day we have exams after the classes or
No, we don't have
assignments.
it is the tests are scheduled. One after, see, for example, after covering all the Unix topics, you will be having test on Unix. After covering all the
Okay, sir.
concepts of TCL, you will be having test on Tickle, like that.
So, sir, from initial, I just want to ask who is the mentor or who is going to guide us from the industry. I just want to know his names. Why? Because I just want to know who is the person who are going to teach us.
See, that depends upon who is available during the PD advance time, right? We cannot guarantee only he will teach. Who is available during the PD advance, they will support you.
Okay.
So
Initially,
whom
you
you
are
want?
there for yeah.
Whom you want?
What?
You can
What,
shift to
sir?
their batch. Whom you want? if for example this batch you for one mentor is there and you are not comfortable with him, right? You tell that okay, I will
Okay.
shift to some other batch after 1 month, then you can join to his batch only.
So it is possible to interchange from one batch to another.
Yes. If you
Okay, sir.
telling at the beginning only, okay, first I attended, I'm not comfortable, so I'll go to next batch. Whom you want, you tell me. I'll tell whether he cannot do or not. Do you have any idea
Okay,
about
sir.
our mentor?
No, sir.
Okay, then how can you tell? Right? How can I ask this, right? No,
No,
if you have any
usually
idea, then I
from
can tell
beginning,
you whether he is doing or not, right? Based on that only, I can confirm whether he is
no,
doing.
no. From initially you are talking now, you have 10 plus of experience. So I thought you are the person who is going
Yes,
to
yes,
teach
see,
us. That's why.
yes, yes, see, we have 3 to 4 trainers. So who is available? All are good, right? Even it's not like that. I am only experienced. All are experienced and who has knowledge of industry, right? Then they only do it. Without see, we do something, and if that person is not going to place, it's problem for institute only. So as you have responsibility, we have responsibility, right? We will take care about that, and the trainer will be a good trainer. And if you feel you are not comfortable, you can change the batch without any cost.
Okay.
You so,
Okay,
but
sir.
you should tell at the beginning only, right? You cannot tell at the last.
Okay, sir.
After few 5 to 6 classes, you can take a call. You can change. See, ultimately, your interest is valued, right? Your interest. So you tell that, see, I will work day and night. You keep the institute open. We will do that because ultimately you have to show the interest and you have to come up with the thing. You tell, okay, I don't want this mentor. I want that mentor. Will change. Okay, you tell that, see, for every weekend I have few doubts. You please arrange a support session. We will do that, right? So ultimately, we should get the good knowledge and you should get placed. Then only institute will get their credibility. So for that reason, we are able to do that. Yes, thank you everyone. Right? Because already it's 4 hours
Yes, sir.
exceeded.
Thank you.
Thank you.
Sir, what is your good name, sir? I forget it, your name.
Pratik.
Pratik. Okay, sir.
Thank you. Thank you.